Okay, good morning. Right. So today we want to finish your maths, okay? Probably this will be your last session. So because we have done 2020, 2021, 2022, okay? So 2019 also we did questions other than 3 questions. So let's do those last 3 questions in 2019 paper. So then that is also done. Okay, because 2020, I think we have done it for 2 batches. Other batch, I will share it today itself. I will share the 2020 recording. Okay, right. So let's finish that last 3 question. And then we'll do some random questions. Okay, from different model of questions from other past papers. Right. So we just need to do the last 3 questions. So let's do those 3 questions. Okay. If 2 to the power 2, 4 to the power 2, 6 to the power 2, 8 to the power 2, 4 into the power square 2 is this. Okay, is this. The question is then 2 squared plus 4 squared plus 6 squared plus, so that is basically what they need is the square of these numbers. Okay, so how do you do that? Do you see any pattern? So 2 squared, remember we know arithmetic sequences, we know geometric sequences. So can we use that knowledge? So I'm also now thinking, anyone has idea? Anyone has an idea? So the general pattern is 4n squared. Right? 4n squared. So that means 4 times 1 squared plus 4 times 2 squared plus 4 times 3 squared and so on, right? 1 squared is 1. 1 into 4 is 4, correct? 2 squared is 4. 4 into 4 is 4 to the power 2. Then 3 squared is 9. Is it 9 into 4? Yes. So 6 is 2 into 3. That is 2 squared is 3 squared. 3 squared into 2 squared is 4. Correct. Right. So therefore, nth one is 4n squared. Now, can we find a way to do it? No, they have given the formula, right? So therefore, it's easy. Right. It's easy. So now just we have to find out what is this 220 squared. Right. So that is not a difficult question. I thought it difficult question, but it looks very easy. Right. So then this is 8 squared is 4 into 3 squared. So likewise, what is 20 squared? So 20, we have to write it as, remember we write 6 as 3 into 2. 8 as, say 4 as 2 into 2. 6 as 3 into 2. Right. So, sorry, 2 into 1. So this is 1, this is 2, this is 3. So therefore, next one will be, how do you find the pattern? Okay, let's again see the pattern. There's a pattern. If you can see the pattern, that's the end of the story. We can do it. So can we see the pattern? So 2 squared is 4 into 1. Okay, 4 into 1 squared. 4 squared is 4 into 2 squared. 6 squared is 4 into 3 squared. That is 2 square, 3 squared, 2 squared. Okay. Then 8 is 4 into 4 squared. Because 8 is 4 into 2. 4 into 2 squared is 2 squared is 4, then 4 squared. Then what about 20? Always we need a 4. So therefore, I'll write it 20 as, okay, likewise, 20 is 20 into 20. Okay, 20 into 20. So then I need to take 4 as a common factor because everywhere you can see we have 4. 4, 4, because this pattern need a 4. 4. So I'm just thinking now, okay? I'm just thinking a possible solution, right? So this is also 4. So therefore, I will write this as 20 into 20, but I need a common factor 4, right? I need a common factor 4. So therefore, I'll write 20 as 4 into 5, right? Into, that's it, 4 into 5 into, but I need 4, right? So therefore, 20 is 4 into 5, then 20, right? Then 20, then I have the 4, okay? So then it is, remember I'm writing 20 squared, okay? So that is the last term. 20 is 4 into 5 into 20. So then I have to write it as a square. So that is 4 into 100. 5 into 20 is 100. So yes, 100 is 10 squared. So therefore I can write it as 4 into 10 squared. Right? So therefore what is 20 squared? That is 4 into 10 squared. Now we are done. Now we are done. So therefore 4 into 1 squared, 4 into 2 squared, 4 into 3 squared, and so on. 20 squared is 4 into 10 squared. So therefore n is, last terms n is 10. So therefore now I can use this formula with, because this is up to n terms, sum of up to m terms. Now what we need is up to 10th term, because this is 10 squared. So therefore I can use this with n equal 10. Okay, so therefore now I am done. So 2 into 10, I'm using this formula, into 10 plus 1 is 11, into 10 into 2 is 20, 20 plus 1 is 21, divided by 3. And this is 7, right? So then 11 into 7 is 77. 77 into 2 is 154. 154 into 10 is 1540. So the final answer is 1540. So remember, initially I was also very confused, but after looking at it, I'm keep looking for some patterns. So I got the pattern, right? So it's 4n squared pattern is 4 into 10 squared. So therefore n is 10. So therefore then I use this, because this is given. So I just use n equal 10 here. So the answer must be 1540. Okay, 23rd. C, correct. Answer is C. Okay. Fine. So what about the 24th? Any question on that? So you had complete 1 week to have a look at it, right? If you are interested in your maths paper and want to pass it, of course, if you are not very serious, right, you can just go to the exams and accept whatever the result. Okay, කරුමේ ලබා උපන් හැටි ඉරණම කියලා බාර ගන්න. ඔයාගේ සංස්කෘතිය ඒක නේ, අපේ සංස්කෘතිය ඒක නෙමෙයි. හරි? අපේ සංස්කෘතිය අපිට ඕන ඉලක්කයට යන්නේ. That is our culture. I don't know about your culture. Right? 24. If the sum of the first n terms of an arithmetic progression is n squared plus 2n, then the common difference is. So anyone did that? Of course, most of you guys must have done it. If the sum of the first n terms of an arithmetic progression is n squared plus 2n, then the common difference is. How do you find it? Can anyone suggest me? I don't need the answer. Can anyone suggest me a solution? It's arithmetic progression. Anyone? නිකන් වාක් එකකින් කියනකොට මේ වගේ කරොත් මේක හදා ගන්න පුළුවන්. නැත්නම් මම මෙහෙම තමයි හැදුවේ කියලා මේ ස්ට්‍රැටජි එක පාවිච්චි කරලා කියලා. Because this is a very common question, right? No one? දැන් මේකට උත්තර දෙන්න නම් ගණන් පුළුවන් වෙන්නත් ඕන, logical thinking පුළුවන් වෙන්නත් ඕන, ආත්ම ශක්තියක් තියෙන්නත් ඕන, leadership skills තියෙන්නත් ඕන. Right. So remember this is Sn, n squared plus 2n, right? Sum of the first 10 terms. So if I know the sum of 10 terms and sum of 11 terms, so 11 sum 11 minus sum 10 is what? The 11th term. එතකොට අපිට එනවා 11th term. එහෙනම් අපිට ඒ වගේම 12th term එක හොයාගත්තොත් එimhe 12th term minus 11th term is a common difference. ඉතින් අපිට 11th 10th වලට යන්න ඕනේ. We can just take the first term, sum of first term, sum of second term. Right. So sum of first term is first term. Right. That's it. Yeah. Find the difference of two consecutive terms. ඉතින් ඒක කරන්න ඉස්සර sum වලට යන්න ඕනේ. So therefore I can write S1 when n is 1, 1 squared plus 2 times 1, that is 3. So that is sum of first term is first term. So therefore this is my A. Then what about sum of two terms? You have to apply n equal to 2 squared plus 2 times 2. That is 2 squared is 4, 2 into 2 is 4, 4 plus 4 is 8. So that is first term plus second term is 8. First term is 3. So if this is 3, what is the second term? N2 is, so this is A. The T2 is, this is A or T1. So therefore T2 is, because we know that this is 3 and sum is 8. So therefore this must be 8 minus 3. Right, 8 minus 3 because this is 3. Pure logic. So that is 5. So now I know the second term. This is the sum of two terms. Now I know the first term, which is 3. I know the second term, which is 5. So therefore, what is the common difference? Second term minus first term. Because any two consecutive terms, the difference is going to be the same. So therefore, 5 minus 3, which is 2. Right? So therefore, common difference is 2. 24 answer is A. Right? A. So they check whether you are intelligent enough. That's it, right? Of course, there can be questions which even I can't do. Because that is how maths papers are, right? Otherwise, everyone going for the A-level maths also will get 100 out of 100 out of 100 out of 100. Sometimes even when it comes to A-level maths paper, sometimes even examiner can't find the answer. So complicated. But these are not that kind of complicated questions, okay? But there can be complicated questions. But 99% of the questions are doable questions. Right, next, final one, 25. A sports club member can be either swimmer, gymnast, or tennis player. So what are the possibilities? Swimmer, gymnast, or tennis player. Swimmers make up 1/8 of the total number. Swimmers, 1/8 of the people are swimmers. Gymnasts take up 3/4, 3/4. The rest of the members are tennis players. Okay, rest of the members are tennis players. Okay, 1/8, 3/4. Yeah, rest of the players are tennis. Rest of the members are tennis players whose numbers amount to 20, and that value is 20. How many swimmers and gymnasts are there? So it's super easy, right? So if 1/8 is swimmers and 3/4 is gymnasts, what portion is tennis players? So that is 1 minus 1/8 plus 3 divided by 4. That is 1 minus 8 is a common denominator. 1 plus 6, because 3 upon 4 is 6 upon 8. That is 1 minus 7 divided by 8. 1 minus 7 divided by 8 is what? 1 divided by 8. So therefore this portion is, right, now we found that portion 1 divided by 8. So 1 divided by 8 is 20. So therefore, this is also 1 divided by 8. So therefore, this must also be 20. Okay. Now, of course, we know the total number of, sorry, 3/4 is this one. If 1/8 is 20, okay. So what we need is 3 out of 4 is same as what? 6 out of 8. 8න් එකක් කියන්නේ 20 නම් 8න් 6ක් කියන්නේ නේද? මේ වගේ 6 ගුණයක්. Right? Common sense. So if 1/8 is 20, what is 6 out of 8? 6 times this, 120. Okay. So therefore, how many swimmers and gymnasts? That is 20 and 120. Answer is D. Okay. Answer is D. Yeah, 24th question. Okay, let me explain the 24th again. So I'll explain it from the beginning again. So I hope 25th question is clear. It's just a normal ratio question. Right. So this question says it's arithmetic progression, arithmetic sequence. Okay. And if the sum of the first 10 terms, that is Sn, equal n squared plus 2n, that is given. So they ask common difference. So if I know sum of n terms, general formula, I can find sum of one term. Sum of one term means basically the first term, which is 1 squared plus 2 times 1. That is 3. So that is basically sum of first one term means the first term. So therefore, this is my T1 or A. Right. So if I know the second term, then I know the common difference. Second term minus first term, because I don't have to look for 5 and 6 or 10 and 11. Any two consecutive terms have the same common difference. That is why they say it's an arithmetic progression. It's not a geometric, it's arithmetic. So then I can find S2 or S3 or whatever. I just need two consecutive sums. So S2 is 2 squared plus 2 times 2. That is 8. That is S2, right? That is not T2, that is S2. S1 is same as T1, but it doesn't mean that S2 is same as T2, right? So now we know that the first term is 3. First term, which is 3, plus second term is 8. So therefore, what is second term? 8 minus 3. So therefore, second term is 5. If I know the first term and second term, common difference is second term minus first term. Difference between Tn plus 1 minus Tn. So therefore, T2 minus T1 is 5 minus 3, which is 2. So that is how you got it as common difference as 2. Right? You can do it for any two consecutive numbers, but the easiest is take S1 and S2 and find T1 and T2. So this is a model question, a popular type of question you get. So therefore answer is 24A. Right? I hope it's clear. Right. So now we have done actually not 3 papers, we have done 4 papers. 19, 20, 21, 22. Okay. Now what we do is we'll do few more questions. Okay. Random questions which are sort of a typical questions you might get. Okay. Past papers පුළුවන් තරම් කරලා යන්න ඕන maths වලට. I don't say that for information system, computer system, maybe 3 years is enough, but it's always good to do at least 5 years. But maths, do as much as possible. Because the maths study කරන්න කියලා දෙයක්වත් නැහැ. Right. So now let's take 2018 paper, and I'm not going to do all the questions. I'll be doing some selected questions only. Okay, some selected questions only. Because I don't want to do similar type of question 2 times. Okay. Right. Do the first one quickly. Do the first one. The price of a brush, serviette, and coaster are 5x minus 2, x plus 4, and 2x. Assume that Jane purchases 1 unit of each above items and nothing else on her shopping trip. The average amount of her total bill is 62. Which of the following statements are true? Right, quickly do it. Those who have not done it. Of course, you had enough time to do all the past papers now. And you must be able to do it within two minutes, not more than 2. Right, so it's an easy question anyway. The price of a brush, serviette, and coaster are 5x minus 2, x plus 4, and 2x. Assume that Jane purchases 1 unit of each of the above items, 1 unit of each, and nothing else on her shopping trip. The average amount of her total bill is 62. Average amount. Average amount means add these 3 and divide by 3. Right. So average amount means average amount that she spent for one item. Okay. So therefore, 5x minus 2 plus x plus 4 plus 2x divided by 3 is 62. Now it's super easy. So 5x plus x, 8x. Right, 8x. 4 minus 2 is plus 2 is 62 into 3. Okay. So therefore, 8x is 62 into 3 is 186. 186 minus 2 is 184. So therefore, x is 2, 16, 24, 23. So now we know x is 23. X is 23. So now we can calculate which of the following statements these are true. So now we can find the serviette and coaster cost the same. Serviette and cost. Okay, let's find these values. This is 2 into 23, and that is 64, 46. This is 23 plus 4, 27. Okay, so this is 5x, that is 23 into 5, 115, 115 minus 2, 130. Right. So the serviette and coaster cost the same, no. The brush cost 120, no. The range of the 3 items, prices, range means the biggest minus smallest. That is something you have done in your O-level. Range means the biggest minus smallest. So biggest is 113, smallest is 27. So 13 minus 7, 6. Then this is 0, 10 minus 2 is 8, 86. Yes, range of the 3 items prices is 86. So remember, range is largest minus smallest. The lowest price is 27, correct. The coster costs 56. No, coster costs 46. So therefore answers are C and D. C and D. Right, so let's double check the answer. C and D. Answers are C and D. That is how you do that kind of question, right? Right. So do the second one and third one also. Second one and third one. Right. So let's do this. Now you must you must be familiar with the words, right? Because we discussed these words. So when you have fraction, right? So we call this numerator. This is called denominator. If you don't know the names, of course, you can't do these questions. So that is why we did it in the English medium. Right? Denominator of a fraction, that is the lower part, is 2 more than its numerator. That means if numerator is x, denominator is x plus 2. Right? The sum of the fraction, that fraction and its reciprocal. Reciprocal means 1 over value. So if this is number, reciprocal is 1 over 5. Right? If this is your number, reciprocal is 3 over 2. So sum of the fraction and its reciprocal. So therefore this plus its reciprocal, that is this, it is 10 divided by 3. So I'm doing this question because maybe you are not very familiar with the word reciprocal or numerator and denominator. Maybe you have not, right? So that is why I'm doing some more questions. Right. So now what they ask is, what is the fraction? Now, of course, you can find x. Once you find x, the fraction is x divided by x plus 2. Right. So let's do it. So let's do it. Now I can take x as the common denominator. It's a little bit time consuming, but we have to do it. So then x squared plus x plus 2 squared is x squared plus 4x plus 4 is 10 divided by 3. Is 10 divided by 3. Then x squared plus x squared is 2x squared. 2x squared, I can take x, like 2x squared plus 4x plus 4 is x times x plus 2 times 10 divided by 3. So I can see 2 is common, therefore I want to take 2 out. Okay. So therefore, now this is sorry, this is 2x squared plus 4x plus 4. Yeah, so 2 is common here. So therefore, I can take 2 out. So then x squared plus 2x plus 2 is, then 2 to 2 get cancelled. 5x divided by 3, x plus 2. Okay, 5x divided by 3, x plus 2. Now I can cross multiply. Then 3x squared plus 6x plus 6 equal 5x squared plus 10x plus 10x. So now I can simplify. I take this also the other side. 5x squared minus 3x squared is 2x squared. The 10x minus 6x is 4x. Minus 6 equals 0. 6 also I took it there. Then I can take 2 also out. X squared plus 2x minus 3 is 0. Now, do we have factors? Yes. Minus 2. Sorry. What are the factors? Minus 3 and plus 3 and minus 1. X squared plus 3x minus x minus 3 equals 0. Minus 3x minus x is 2x. Now I can take, maybe I will write minus x here, 3x there. Okay. Because otherwise I can't factorize it. No, still I can factorize, right? Yes. Yeah, still I can factorize. So I'll factorize as it is. I can take x out from the first two. X plus 3 minus 1, again x plus 3 equals 0. So then x plus 3 is common. X minus 1 equals 0. Now I have x equal 1 or x equal minus 3. I have two answers. Right? So now let's see what are the answers. Remember they asked what is the fraction. So fraction is x divided by x plus 2. Right? X divided by x plus 2. So therefore first possibility is when x is 1, 1 divided by 3. That is first possibility. Second possibility is when x is minus 3 divided by minus 3 plus 1. That is minus 1. So that is again, that is 3. So there are two possibilities. One is 1 over 3. Other one is 3. Okay. But remember, but this can't be the case, right? How can we get two answers? So this answer is okay because this is 2 plus this. But what about this minus 3 divided by minus 3 plus 2? That is plus 3. How did you get two answers? Anyway, 1/3 is there. I'm just wondering why we got 3 also as answer. Yeah, 3 is also there. But is 3 correct answer? Denominator of the fraction is 2 more than its numerator. 3 million pulan. 3 divided by 2 more than. Minus 3 minus 1 ke liyan pade. Minus 3 divided by minus 3 plus 2. Yes, right. Minus 3 divided by minus 3 plus 2. No. Oh. Then minus 3 divided by minus 1. Yes. So that is also answer, right? So this is also correct. Minus 3. Denominator is 2 more than the numerator. Yeah. So therefore, both the answers. So what are the answers? 1 divided by 3 and 3. Anyway, both the answers are there. So therefore, we can take both. We can take both. So therefore, answers are C and D. Let's see whether the answers are correct. Oh, they have taken only C. Why is that? because 3 is also correct, right? So if you take 3 plus 1 over 3 is 10 divided by 3. ඔය එන්නේ එකත් හරියට. මෙයා fraction එකක් කියලා ගහන හන්ද සමහරට මේක ගන්න නැතුව ඇති. මොකද මෙයාගේ reciprocal එක නෙමෙයි. So maybe that is the only reason examiner has not taken 3 as answer, because if this is the answer, this is the reciprocal. But they say what is the fraction? But anyway, 3 also can be written as a fraction. But this is not really the fraction, it's a reciprocal of this one. So therefore, maybe that is the reason examiner has not taken this one. Because it's not a proper fraction, right? It's not a proper fraction. It's basically a whole number, right? But anyway, both the answers are correct. ඔය කියන satisfied ඔය දෙකම. මොකද මේක 3යි කියලා ගත්තොත් reciprocal එක කෑට 3යි කියලා ගන්න පුළුවන්. Right. Right. So third question, anyway, I don't have to do it. You can do it, right? 50 plus 1 over 50 plus 1 over 50 squared, you must be able to do it. Right. Chat එකේ තියෙන මොකක් හරි question එකක් දාලා. Question number 17. Okay. Let's see what is question number 17 first. දැන් තමයි මට ඒක අතෑරුණා. Right. Question number 17. කරපු නැති යට අගර කරන්න බලන්න. Question number 17. මේ වගේ question අපි කරා. ටකල් කරන්න. I'll give you 2 minutes. මේ වගේ කරන්න පුළුවන් කෙනෙක් සෑහෙන්න. හරි වාට පාස් වෙන එක ගැන කිසිම සැකයක් නැහැ. No doubt about your introductory maths paper. That means your confidence is really high. Just do it. Okay, right. So let's do it. Remember, we want to take it to AR n minus 1. So then S infinity is, if R is between -1 and +1, given R is between -1 and +1, S infinity is A divided by 1 minus R. Okay, so that is the theory. Therefore, first let's see whether we can take it to this format. And remember, sigma An plus Bn is sigma An plus sigma Bn. Sigma K times An is K times sigma An. So those are the other two things that we can use. That's it, nothing else. ඔච්චරයි පාවිච්චි කරන්නේ. ඒ කියන්නේ මැත්ස් කරන අය බොහොම ජොලි ඉන්නේ. ඔළුවේ කටපාඩම් මතක තියාගන්නේම මුකුත් නැහැ. ඒගොල්ලෝ දැක්ක තැන හොඳට hina වෙලා ජොලි ඉන්නවා. අනිත් අය හැමෝම තිස්සෙම අරක කටපාඩම් මේක කටපාඩම් අනිත් එක්ක කටපාඩම් අන්තිමට මොලෙත් මඤ්ඤම් වෙලා කටපාඩම් කළා. Right, so let's do this. So I need AR n minus 1. Okay, ඔන්න ඔක දැන් කරන්න. So this can be a constant. So I'll write it as මම මේක වෙනම කොලයකට ගන්නම් නැත්නම් අපිට ඉඩ මදි වෙයි. Right. Sigma, of course, 1 to infinity. 3 times 2 to the power b plus 1 divided by 2 to the power 2b minus sigma 2 times 2 to the power b minus 1 divided by 2 to the power 2b. When we need AR n minus 1. Okay, n minus 1, b minus 1. So this is sigma 3 times 2 to the power b plus 1 minus 2b. Division is subtraction. Okay, minus sigma 2 times 2 to the power b minus 1 minus 2b. Okay, so that is sigma. I can take 3 out if you want, but anyway, let's keep it. 3 to the power 3 into 2 to the power minus b plus 1 minus sigma 2 times 2 to the power b minus 2b is minus b minus 1. What I need is AR n minus 1 or b minus 1. B minus 1 then minus b plus 1. So that therefore I'll write it as, remember what I'm looking for is AR n minus 1 format. Then it is a geometric series nth term. So therefore I write it as sigma 3 times 2 to the power. Maybe I can take minus out. Minus ගන්න පුළුවන්. n minus 1. How can I write it? I need b minus 1. If I take minus 1 out, b plus 1. Okay, let's try it. 2 times 2 to the power minus 1 out, B plus 1. Okay. What I need is B minus 1. But what I have is this one, right? Okay, so we'll do something else. Okay, so let me erase this because I need not minus B, I need B minus 1, right? Right, so let's do it like this. Say sigma 3 times. I'll take this to the below. Okay. That is 1 over 2 to the power 2B minus B is B minus 1. Okay. So B minus B B plus 1 I took it to the below. So 2B minus B minus 1 is 2B minus B is B minus 1. Okay. Minus sigma 2 times 1 over 2 to the power 2B minus B minus 1 is 2B minus B is B. Minus 1 become plus 1. Okay. Now I can write this one also as 1 to the power B minus 1. And this one also has 1 to the power B plus 1 because 1 to the power any number is the same. Okay, so therefore now I can write it as sigma 3 times 1 over 2 to the power B minus 1. Okay, remember A to the power n divided by B to the power n is A divided by B to the power n. So similarly, this one I can write 2 to the power, sigma 2 into 1 over 2 B plus 1. Now this one is okay now, A R n minus 1. But this one is not, right? This one is not. So now this one is okay. This one is, I don't have to do it process further, 3 times half to the power B minus 1. But this one, I will write it as half to the power B minus 1. I can't change the value. B minus 1 plus 2. Because minus 1 plus 2 is plus 1. I am not changing. So I am not supposed to change numbers. But I'm rearranging. So B plus 1, I write it as minus 1 plus 2. Because I want B minus 1. Okay. So now I can write it as sigma 3 times half to the power B minus 1 minus sigma 2 into half to the power B minus 1. So this is plus means multiplication. So that is into half to the power 2 B minus 1 plus 2. I'm not changing. Right? So therefore now I can take this as sigma 3 times half to the power B minus 1 minus this half power is 1/4. 1/4 into 2 is half. So remember this is 4. 2 divided by 4 is 2. Half to the power B minus 1. Now I have ARN minus 1. ARN minus 1 and R is half. R is between minus 1 and plus 1. Right. So therefore now both are convergent because ARN minus 1 and R is half. Therefore this is when ARN minus 1 and when R is between minus 1 and plus 1, S infinity is A divided by 1 minus R. So therefore this one, A is 3. 3 divided by 1 minus half minus this one again A is half. So this is A is also half. Half divided by A divided by 1 minus R. R is also half. So therefore what is the final answer? 1 minus half is half. 3 divided by half is 3 into 2, 6. Minus 1 minus half is half. Half divided by half is 1. 6 minus 1 which is 5. Do we have 5 as answer? Yes, 5 is, there's a 5 as answer. So answer must be A. Answer must be A. So let's first check the answer. 17. Yes, answer is A. Okay, answer is A. So that is a challenging question, but if you do it properly, because you must have an objective. We have done these kind of questions, right? But what we would do is get AR in -1, and we know that the two rules. Okay, so therefore I just kept simplified. First I went little bit straight. මාව පොඩ්ඩක් අර වැරදි පැත්තකට දඩාව තිය ගියා. ආයි හරි පැත්තට ආවා. So that is how we do. Right? වැරදුනා වැරද්ද හදා ගන්නවා. Right? So I took it and I break it because there's a rule for that. So then I just write it as AR n -1. This is straight away I got it. But this one I got it as 2B+1, but I can rearrange so that B+1 is B-1 plus 2. Then of course this addition is a multiplication in indices. So therefore I just took it out and I simplified it with this. So then I again got AR n -1, AR n -1. I got the same R also, and R is half. When R is between -1 and +1 is converge to A divided by 1 minus R. So I use that formula here and here. Then I got 6 minus 1 answer as 5. Okay. So first two steps. So that is our rule. So remember we did the rule. We did a rule. Sigma AR plus BR or plus or minus equals sigma AR plus or minus sigma BR. So that is the rule. So I applied that. Sigma when that is the first step. So then second step is basically I simplified this. Right? A to the power n divided by A to the power m is A to the power n minus 1. ඉතින් මම මේක යට පැත්තටයි ගත්තේ හැබැයි. යට පැත්තට ගත්තා. So 2b minus b minus 1 is b minus 1. එතකොට මම 1 කියන එක ආයේ b minus 1 හදා ගන්න ඕනද? එකේ b minus 1 කියලා ලියුවා. ඒක ලියුවට වැරද්දක් නැහැ නේ. එකේ බලයක් ඕන බලයක් එකමනේ. So this is 2b minus b plus 1. Right? 2b minus b plus 1 is b plus 1. ඉතින් මම යාවත් b plus 1 කියලා ලියුවා. එතකොට මට භාගයේ b plus 1 කියලා ලියා ගන්න පුළුවන් වෙනවා. මොකද මට AR n minus 1 විදිහට හදා ගන්න ඕනේ. මොකද ඉස්සෙල්ලා එහෙම හදාගෙන ඉවරලා ඊට පස්සේ මම ලියුවා මේක -1 plus 2 කියලා. එතනත් වෙනසක් කරේ නැහැ. එතකොට මට b minus 1 එනවා. AR n minus 1 එනවා. එතකොට මෙතනත් ආයේ එකතු කිරීමක් කියන්නේ වැඩි කිරීමක් කියලා කඩලා ගත්තා. මොකද ඒක constant. Constant එක මට අවුලක් නැහැ. So then that constant can be simplified with this constant. So then I got AR n minus 1 format. Then I can apply this rule. It's a bit of challenging question, right? But should be doable. Should be doable. Okay. So that is 2018 paper. Right. So let's do some more questions. I'm just selecting random question, and also you can also tell me which questions you want me to do. Okay. I'm not doing the very easy questions. Right, do this. Somebody may question එකකට එන්න ඉඩ තියෙනවා. Straight line formulas මර්ග තියෙන්න ඕන. සරල රේඛා සමීකරණ. Do the ninth one. Remember the pass mark is 50, but don't go to this examination thinking that I will get 51. So you try to get as much as possible. මම නම් සාමාන්‍යයෙන් maths paper එකට යන්නේ CNC ගන්න බලාගෙන. CNC කියන එක මට එච්චර අමුතු දෙයක් නෙමෙයි. 1 2 3 4 5 6 පන්ති වලදී නම් හරි. ඉතින් ඊට පස්සේ CNC ගන්න ගියාට මොකෝ අපිට එන්නේ ගොඩක් වෙලාට 90ක් 80ක් තමයි. So that is fine, right? හැබැයි 51කට යන්න එපා. And remember pass mark is 50 here. This is introductory maths EN subject, not IT subject. Pass mark is 50, not 40. And if you fail maths, you can't go to level 2. Right? So other thing, so when you go to the exams, make sure you mark your correct answers in your answer sheet. හරියට මාක් කරන් එන්න. Because after the exams, within 2 weeks, they publish the answers in the university site. BIT site එකේ answers publish කරනවා. answer sheet එක. එතකොට ඔයාට සති දෙකකින් පස්සේ ඔයා results දන්නවා. results දෙනකන් ඉන්න දෙයක් නැහැ. Because you have marked your answers, because you can take the answer sheets home. You have the exact answers that you mark. So they publish the answer sheets within 2 weeks. So then you know for each and every subject, which subject you get A, which subject you get A, B, and which subject you fail. එතකොට introductory maths එකට 50ට අඩු නම් බා දන්නවා semester 2 කරන්න පුළුවන් අඩු. You can do the semester 2. But you can't go to the level 2 next time. ඔයාට ආය අවුරුද්දක් ඉන්න වෙනවා. ඒ කියන්නේ මම මේ maths වලට මෙච්චර ලොකු බරක් දෙන්නේ. ඕක විභාගෙට ගිහිල්ලා ඇවිල්ලි වල බොරුවට අප්මයෙන් ආනවා. සමහරව ආන මේ maths fail වුණොත් එimhe මොකද වෙන්නේ කියලා. මම ඒවට උත්තරයක්වත් දෙන්නේ නැහැ. ඒ බබා හුකුම් වෙන්න හදන කට්ටිය. පොර පාරක් නැද්ද මේකේ පාස් වෙන්න? UCSC එකට කියලා අපිට level 2 කරන්න පුළුවන් නෑ එහෙම බෑ. නැත්තම් පිකට් කරන්න පුළුවන්ද නේද? කට්ටිය ගිහිල්ලා උද්ඝෝෂණයක් කරන්න පුළුවන්ද maths paper එක පාස් කරන්න? ත්‍රස්තවාදී වගේ ඒව බෑ. ඒක කලි බවුසරත් තමයි අල්ලන්නේ. පිකට් කරන්න આવත්. Right. What about the ninth question? වැඩේ හරියට කරන්න ඕන. කරනවා නම් නැත්තම් නොකර ඉන්නවා. කම්මැලි කමට තක්කටි කමට කරන්න බෑ. IT maths. Okay. Right. What is the equation of the line perpendicular to the graph y equal 3x minus 2? Y equal 3x minus 2. Sorry, y plus 3x. Sorry, not y equal. Y plus 3x minus 2 equal 0. Okay. So therefore now y equal minus 3x plus 2. So therefore gradient is minus 3. Right? Gradient is minus 3. Right? Okay, just give me 1 minute. Right. Okay. So gradient is minus 3. So therefore, if the other line is perpendicular to this one, right, its gradient must be 1 over 3, because minus 3 into 1 over 3 is minus 1. So m1 into m2 must be minus 1. Right. So therefore, other gradient must be 1 over 3. Any straight line having gradient 1 over 3 is perpendicular to this one. So therefore, now it's very easy. Right. So this is not 1 over 3. This is not 1 over 3. This is 3y equal 3. So now we have to take it to y equal mx, right? So therefore y equal minus x become plus 1, then divided by 3. Yes, this is correct. This is correct. This is 1 over 3. This is correct. This is just 1 y equal 3. So this is not correct. So the answers are C and D. Right? C and D. So the ninth one answers are C and D. So C must also be answered. Okay, C must also be answered. Right. So we'll take a break. After the break, we'll do few more questions. Right. After the break, we'll do few more selected questions, and then we'll move on to programming as well. Okay. Right. So now it's 9:05. We'll be starting at 9. Right. So we'll be starting at 9:20. Okay. Okay, so let's continue. So let's do a few more questions. Right. So we'll try to do different type of questions, and of course, if you have any questions, you can ask. Right, we can do those questions as well. I don't do the obvious questions. Right. So let's take another paper, maybe 2017. Right, now do the 37 question because we did similar question. 37 question. You can see when you do a question of a particular type, you are in a position to do a similar question because same type of questions repeat. That is why it's very important that you do as much past paper questions. Sum of the n terms of a series is Sn 5a minus 3n squared divided by 2. Then the fourth term of the series is okay, the sum of n terms of a series. It has not mentioned whether what kind of a series is this, okay? Just a series. Then the fourth term of the series is, again, we can use the same concept, right? So the fourth term is sum of 5 terms minus sum of 4 terms. So basically fourth term is S5 minus S4. පද පහක එකතුවෙන් පද හතරක එකතු අඩු කරාම එන්න ඕන මොකද්ද? sorry, fourth term අහන්නේ. පද හතරක එකතුවෙන් පද තුනක එකතු අඩු කරාම එන්න ඕන fourth term. So the fourth term is sum of 4 terms minus sum of 3 terms. Sum of 4 terms minus sum of 3 terms is the fourth term. So therefore S4 is 5a minus 3 times 4 squared divided by 2, that is S4, minus S3, 5a minus 3 times 3 squared divided by 2. මේ 5a ට 5a කැපෙන හැම තමයි බය නැතු දිය තියෙන්නේ. Okay, so minus, so therefore this will be plus. Okay, so therefore final answer is 2 is the common denominator. 3 times 4 squared, so we can take even 3 out. 4 squared minus 3 squared. That is 3 divided by 2 times 16 minus 9. That is 3 into 7 divided by 2. එහෙම උත්තරයක් නම් නැත. මෙතන උත්තරේ වැරද්දක් තියෙනවා කියලා. මම කමෙන්ට් එකක් දාලා තියෙන එකද කියලා. No, right? I must look at the S4 S4 minus S3. S4 is 5a minus 3 times 4 squared divided by 2 minus 5a minus become plus 3 times 3 squared divided by 2. 5a to 5a get cancelled. I can take 3 out. This is minus, right? Yeah, so this is minus 3 times 4 squared. So therefore, there must be minus here. Right. So then, when I take 3 out, minus 4 squared minus 3 squared, right? So therefore, this is minus 16, right? Minus 16. I took. So let's do it again because I missed here. Right. So 5a to 5a get cancelled. If I take 3 out, minus 4 squared plus 3 squared divided by 2. So that is 3 divided by 2 times minus 16 plus 9. Still minus 7 into 3 නේද? මේ උත්තර නැහැ. උත්තර තියෙනවා. Sorry, මේකේ උත්තර නේ. So therefore answer is minus 7 into 3 divided by 2. That is minus 21 divided by 2. Yes, answer is there. Minus 21 divided by 2. Answer is B. Okay. Answer is B. 37. Answer is B. So this is the time where you had 2-hour paper. Make a 2-hour paper. That is why you have more questions. Okay. 2-hour paper. But now what you get is 1-hour paper. Okay. So this is 2-hour paper and 40 questions. What you get is 1 hour, roughly 20 questions. Okay. Right. So let's do few more questions. I do the 31st question. Right. So remember, when you work with 180 and 30, 360, right? Sine is sine, cos is cos, tan is tan. So that means sine 180 plus or minus theta is sine theta. Cos 180 plus or minus theta is cos theta and so on. Okay. Same for 360. But when you work with 90 and 270, sine become cos, cos become sine, tan become cot. And sine you have to check from all sine, tan, cos. All sine, tan, cos. Right. So now first one, let's write it as sine 135 is sine 45. Remember, sine 135 is between 90 to 80. So therefore, sine is positive. So therefore, yes, this is also sine positive. This is also sine positive. Sine wise equal. Right? Now let's write 135 as sine 180 minus 45. Sine, I'm not changing. 135 is 180 minus 45. So when you work with 180, sine is sine, cos is cos, tan is cos, tan is tan. So therefore, this is sine 45. And both are positive. So therefore, yes, sine 45 is equal to sine 135. So this is correct. Okay. Right. So this one is strange one. Cos 65 and sine 25. Okay. Just let's keep it as it is for the time being. What about the next one? So this is something you know. You know the sine, cos, tan values of, right? Sine, cos, tan values of well-known angles 0, 30, 45, 60, and 90. 0, half, 1 over root 2, root 3 divided by 2, and 1. Okay, so then this 1, root 3 divided by 2, 1 over root 2, half, and 0. And tan 45. So then tan is sine divided by cos, 0 divided by 1 is 0. This is 1 over root 3. This is 1, this is root 3, and this is infinity. So therefore, tan 45 is 1. Cos 60 is half. So therefore, these two are not the same. Okay. So then what about this? Remember, sine and cos has opposite. Right. Remember, sine 30 is cos 60. Right. Sine 30 is cos 60. Sine 60 is cos 30. Okay. So therefore, cos 90 minus 65. Oh, we can say sine 25 is same as when you play with 90, sine 90 minus 45. Sorry, sine 90 minus 65. 90 minus 65 is 25. And when you play with 90, sine become cos. So therefore, this is cos 65. And of course, this in this quadrant, both sine and cos are positive. Okay. So therefore, sine 25 is same as cos 65. Because when you play with 90, sine become cos. So therefore, this is correct. So therefore, answers are 1 and 2. 1 and 2. So you must be very serious about what you learn. So 31 answer is B. Answer is B. Okay. Right. Find 27. Find the answer for question 27. That is super easy question. You can do it within 10 seconds. 10 seconds, not more than 10 seconds. Right. So just you have to assign n equal 8, as simple as that. So therefore, x8 square is minus 31 plus minus 2 to the power 8. Okay. So that is minus 31 plus 2 to the power 8. 2, 2, 2, 2, 2, 2, 2, 2, 4, 8, 16, 32, 64, 128, 256. Right. And it's an even number, therefore plus 256. So 256 minus 31 is 6 minus 1 is 5, 5 minus 3 is 2, 225 plus 225. And we want to find the square root of that because what we need is x8. This is x8 squared. So is it 15? It's 15 into 15, 225. Yeah. Answer is 15. 27 answer is D. 27 answer is C is also answer. Yeah, so it can be plus or minus 15 because square root of 225 can be even plus or minus 15 because minus 15 into minus 15 is also 225. So that is a careless mistake I made. Remember, if square is this, the minus value is also possible. So therefore, plus 15 and minus 15. Okay. So let's look at 2016 paper. What papers in that 2016, 2015, make it. If you go to the Google Classroom, all these past papers are available. Not the University VLE, maybe University VLE also having. How to keep the one. So this should have all the past papers. පිටුන 59ක් තියෙනවා 21 ඉඳලා 22 පේපර් එක විතරයි ඔකේ නැත්තේ 22 පේපර් යුනිවර්සිටි බීඑල් එකේ තියෙනවා. Yeah, up to 2014. Up to 2014 papers are there. Right, any other specific question you want me to do? 'Because unless you have any other questions, this is the last session for maths. Okay, opposite. If you have any questions, we can discuss. Two 2018-15. The next two terms of the sequence. It's an IQ question. It's not a maths question actually. It just check whether you can see the patterns. Nothing else. It's not a maths question. Can anyone see the pattern? It's not a maths question actually. 18 square, 50 square, 98 square. Can you see a pattern? Nothing else. So I'm also now checking 18. Maybe 9 into 2. Maybe 25 into 2. Maybe. No, that doesn't work, right? Can you see the pattern? Still I'm checking. Uh, uh, uh. This is 3 squared, 9 into 2. Maybe this is 5 squared into 2. 100. Maybe this is then 6 squared into 2. Then. Nah. Or 7 squared into 2. 357. Yes, right? Oh, yeah. 3 squared into 2. 3 squared is 9. 9 into 2 is 18. This is 5 squared into 2. 5 squared is 25. 25 into 2 is 50. එතකොට මේක 3 මේක 5 නම් මම මේක 7 වෙන්නේ. ඉතින් ඒක 6 කියලා පස්සේ මම දක්වන්නේ 7 කියලා. This is 7 squared into 2. 7 squared is 49. 49 into 2 is 98. Now I got it. චුට්ටක් බල බල ඉන්නකොට ඉතින් අහුවෙන්න ඕනේ. That is part of your IQ. Okay. So therefore, next one is going to be 357 squared into 2 square root, and next one is going to be 11 square into 2. So 9 squared is 81. 81 into 2 is 162 square root. This is going to be 11, 11, that is 121. 121 into 2 is 242 square root. This is the answer. Right. So this is the answer. So it's IQ question. It is not a maths question actually. See whether you can see pattern. Or the IQ question හරියට pattern වනේ අහන්නේ නේද? Right. Answer is here C. Okay. Answer is C. So just check whether you can see the pattern. So you can see the pattern if you keep looking for patterns. Right. දිගින් දිගට patterns බල බල යනවා. Looking for with purpose. සොයන්නාට සම්භවයි තමයිනේ. හොයන්නම වෙනවා. Right. Any other question? Right. So one student has sent me a set of questions. I think we have done those questions, right? Anyway, let's double check 2021 question 23. එතන ඔය කරා. මේ question එක අපිට කරගන්න බැරි වෙච්ච question එකක් නේ. Yeah, අපිට මට ඒ question එක නම් තාම බලා ගන්න බැරි වුණා. විදියක් ආවේ නැහැ. Right? So this question we tried out in the class also. Anyone has got a way to find this one? මේක කරගන්න විදියක් ආවද කාට හරි? මට නම් ආවේ නැහැ ඔකට විදියක්. Right? So let's keep that because I couldn't find a way to do this one. Okay. So මේවා අපි කරා class එකේ. Right? මේවා අපි class එකේ කරා. Modular arithmetic questions we did in the class itself. So 2020. full paper එක කරානේ. Yeah, මේ modular arithmetic questions එක අපි class එකේ කරා. So we did those questions in the modular arithmetic topic. Right? So those things we did in the modular arithmetic class. Yeah, these questions we did. Now class එකේ කරා. මේ class එකේ නෙමෙයි 2019 paper we fully completed modular arithmetic questions we did in the modular arithmetic session. One by one. Okay. Right. So let's see whether there's any other question that sort of model question. Just check 2014 also. Now, when you get the paper, you must concentrate on the questions that you can do, not something you can't do, right? Exam day is not something you go and study. So some students නේ සමහරු එක්සෑම් එක දෙක ගිහිල්ලා ඉගෙන ගන්න හදනවා. එක්සෑම් එකට ගිහිල්ලා ඉගෙන ගන්න හදන්න බෑ. ඊට කලින් තිබුණ ඉගෙන ගන්න. එක්සෑම් එකට ගිහිල්ලා තියෙන ඔයාගේ තියෙන සම්පත් වලින් සීමිත සම්පත් වලින් උපරිම ප්‍රයෝජන අරන් එන්න විතරයි තියෙන්නේ. එතන ගිහිල්ලා ඉගෙන ගන්න යන්න එපා. හරි. ඉගෙන ගන්න ඊට කලින් අවුරුද්දක්ම තිබුණා. මාස 6ක් සෙමෙස්ටර් එකක්. හරි. මේක නම් ලේසි පේපර් එකක්. This is super easy paper. Right. So now we'll move on to programming. So we want to do few questions in programming as well. Two 2021 fully done, 2022 fully done. 2020, I think we skipped few questions, right? We did 1 to 28, other than question 9 and 10. So let's finish that paper, 2020 programming. Two 2020 question 9 and 10. Question 9 and 10 I skip kare. Because it's related to applets. Okay. And of course, this is SQL question. Right. So I think I briefly explained what is applet is. Okay. So applets are no longer supported. If you want to create applet, you have to create a class extending the applet class. So then you have to override the paint method, init method, depending on the situation. So minimum you have to override the paint method. So you can refer to the applet node in the Google Classroom and also the UCSC node. But anyway, applets are no longer supported by browsers. Okay. Anyway, let's do this question. Consider the following statement written about applets in Java language. They work at client side and so request less response time. Yes, they work at client side because applets are supposed to be loaded to the browser and run in the browser, but the browser must have, or that client machine must have Java runtime environment. So it must have the Java runtime environment. Okay. They work in the client side. That part is correct. So require less response time. So that I don't think that it's a very good answer. But anyway, yes, right, because it's already in the client side. Maybe, but this is not the perfect sort of answer, but we'll take it. They are secure. No, they are not secure. That is why applets are no longer used. Right? Applets are no longer used. They can be executed by browser running under many platforms, including Linux, Windows, Mac OS. Yes. Of course, applets run on any platform. That is why Java is also platform independent. And of course, it is run by browser. But anyway, the bad news is browsers no longer support it because of the security issues. But the statement is correct. So plugins are required on the client browser to execute them. Yes. So the plugins are required because the browser needs the plugin to communicate with the Java runtime environment. But the bad news is, again, these plugins are not supported by web browsers now. But anyway, this statement is theoretically correct. So therefore, I'll go for 1, 3, 4. But unfortunately, 1, 3, 4 is not there. So therefore, let's so definitely 4 is correct. Okay. So definitely 3 is correct. I told you this part is little bit debatable. Right? This part is little bit debatable. They talk about the drawbacks. Sorry for that. Okay. So they talk about what? That can be considered as drawbacks, not the correct answers. So examiner is looking for drawbacks of applets. So therefore, we have to re-evaluate it, right? So remember, now only I got read the question. Right. So they work at client side, so required less response time. That is not a drawback. They are secure. Actually, they are not secure. Right? They are not secure. So therefore, this is not a drawback. Actually, this is a wrong answer. Right? So they can be executed by browsers running on many platforms. That is not a drawback. That is good thing. Plugins are required on the client browser. That is a drawback. So unless you have the plugin, of course, these plugins are also now not supported by browsers. But anyway, this is a drawback. So this is not a drawback anyway. This is correct, but not a drawback. But this is a drawback. Drawback එක කියන්නේ ඒක දින අවාසියක්. Plugins තියෙන්න ඕන කියන එක එක්තරා විදිහකට අවාසියක් තමයි. Okay. So therefore we'll go for only 4. Right. ඔය තියෙන answers වලින් තියන්න වෙන්නේ only 4 තමයි මට නම්. Right. 9. Let's see whether E is the answer. 9. Yes, answer is C. The drawback is you need plugins. Other drawback is it's not very secure. But anyway, they say they are secure. So therefore, I didn't take that. Okay. Right. 10th question. Select from one of the following the classes which are stored in Java SQL package. Right. Remember, Java I/O package has 5 related things. Java SQL package has a database related thing. So therefore, definitely writer, reader can't be. Those are 5 related. Yeah, connection is right. Remember database connection, result set. Eva database එක වැඩ කරද්දී අපිට use වෙනවා. So I'll go for A and E. Yes, A and E. Okay. Right. අපි තව මොනවද skip කරලා ගියේ. Now we can do the rest of the stuff. Okay, අපි අනිත් ටික ඉවර කරමු එතකොට. හරි done කියලා දාමු. 1 to 28 කරේ તો 28 වලින් ඉතුරු ටික කරන්න වෙනවා අපිට. 28 onwards. Right. 28. Select from one of the following the valid byte streams available in Java. ඕක නම් ඉතින් කටපාඩම් විතර තමයි කරන්නේ. මට ඇත්තට මතක නැහැ මොනවද byte stream ටික කියලා. හරි. So you have to refer to the UCSC note and check whether which of these are under byte stream classes. Okay. So I can't remember the exact answer for that one. Okay. 28 මොකක්ද answer එක තියෙන්නේ ඒගොල්ලන්ගේ. කටපාඩම තමයි වලදී. හරි. Everything other than need. Reader කියන එක අරන් ඉත ඔක්කොම byte stream ලු. කියන්නේ byte by byte ගන්න. Right. So let's do the other one. Thread programming we did last time. So therefore now we can do this thread question. Consider the following program written in Java to answer question 29 and 30. Select from one of the following the similar method as start available in thread class. Thread class එකේ තියෙන start වගේ අනිත් method මොනවද කියලා අහන්න. Right. So this is a thread 1 extend from thread class, thread 2 extend from thread class, and they have overridden the run method, and they must call the start method. හරිනේ start method එක තමයි call කරලා තියෙන්නේ. හරි. එකපාරටම object එකක් හදලා කෙලින්ම නමක් දීලාත් නැහැ කෙලින්ම start කරලා තියෙනවා anonymously. right. ඔයාගෙන් අහන්නේ මේක වෙන වැඩේ නෙමෙයි. මේ වගේ thread class එකේ තියෙන අනිත් methods මොනවද කියලා තියෙන්නේ අහන්නේ. මොනවද thread class එකේ තියෙන අනිත් methods? UCSC note එකෙත් එක මේක තියෙනවා අපේ note එකෙත් ඇති. Yeah. Make sure you go through the applets note, our note as well as the UCSC notes. Okay. What are the other methods in thread class other than start? Start වලට අමතරව run තියෙනවා. Sleep ඇති. Some of the important methods of thread class: start, run, sleep, join, get priority, get name, set name, suspend, stop, destroy, interrupt, notify, notify all. Okay, so these are the constructors. So there are some class methods which are coming from the object class. Object class එකෙන් එනවට ඉකුත් තියෙනවා. And මේ තියන්නේ. So these are also methods from object thread class. But remember, these are not from thread class. මෙන්න මේ ටික මතක තියාගන්න. Wait, notify all කියන තුන උතන්ට ගන්න බෑ. අනිත් ඔක්කොම වගේ හරි. Right? So other than wait, notify all, because they are coming from object class, other things. So ඔය තුන අයින් කළා අනිත් ටික අතන හරි. Right? So wait කොහොමද මෙතන නැහැ, notify මෙතන නැහැ, notify all මෙතන නැහැ. So therefore මේ walk කියලා එකක් තියුනේ නැහැ නේද? ඒ බොරුවට දාන්න නැත්තේ. Sleep is there, join is there, stop is there, yield is there නේද? walk කියලා එකක් තමයි නැත්තේ. Similar කියන වචනෙන් එයා බලාපොරොත්තු වෙන්නේ මොකද්ද කියලා නම් මම දන්නේ නැහැ. I hope what they mean is basically other methods in thread class. So I'll go for everything other than D. Yes, everything other than D. හැබැයි හොඳට මතක තියාගන්න මෙන්න මේ method තුන thread class එකේ නෙමෙයි තියෙන object class එකේ inherit වෙන්නේ. Wait, notify all. Okay. What would be the output of the program B when the program executed several times? Several times. So I run කරනවා. Remember, when you start a thread, there's no guarantee. Only thing is all these threads will be given attention, but there's no guarantee. But how much of the attention? How much of the attention? So therefore, now the thread 1 has started, and of course the main thread is also running. Then thread 1 has started, thread 2 has started. So මේකෙන් කොච්චරක් ඉවරලා මෙයා කරයිද කවුරු ඉස්සර වෙයිද අපිට කිසිම ගැරන්ටි එකක් නැහැ. සමහරවිට මේන් එකට කලින් thread එක ඉවර වෙයි. සමහරවිට මේන් එක ඉවරනාට පස්සේ thread එකේ. සමහරවිට මෙයාට පස්සේ මෙයා එයි. ඕන තරම් mix වෙන්න පුළුවන්. සමහරවිට A ට පස්සේ 1 වැදිලා B ට පස්සේ ඊට පස්සේ for example it can be something like A B then 1 2. මෙතන පටන් ගන්නකොට සමහරවිට මෙයා ඉස්සර වෙන්න පුළුවන්. So maybe 1 2 A B, maybe A1 B2, or maybe A1 2 B. ඔය ඕන එකක් වෙන්න පුළුවන්. Or maybe 1 2 AB, or 1 A2 B, or 1 A B2. හැබැයි කොයි වෙලාවකත් 2ට කලින් 1ට කලින් 2 වදින්න බෑ. Aට කලින් B වදින්න බෑ. එහෙම වෙන්න බෑනේ. මේක රන්න මේක වෙන්නේ නැහැ නේ. හැබැයි අනිත් ඕන මික්ස්චර් එකකට යන්න පුළුවන්. Any possibilities is there. Only thing is always 2 comes after 1, B comes after A. Other than that, any possible combinations might be there. Now look at the answers. So you can see 1 2 AB, this is possible. AB 1 2 possible. A1 B2 possible. 1 A B2, that is also possible, right? AB පිළිවෙලට තියෙනවා. Error. I don't think that there's a error unless you have some issue with your computer. මේ ඕන එකක් වෙන්න පුළුවන්. හැබැයි ඔතන තියෙන නැගීම BA12 වගේ එකක්. So that is not answer. Or AB21, that is not. But all these are paired. Because B comes after A, 2 comes after 1. So I'll go for everything other than 30 E. And then I error එන්න හේතුවක් නැහැ මේකේ. Yes, everything other than E. ආපු අර විකාර ක්වෙස්චන් එක තියෙනවා. කමන්න එක කරමු. right. මොකද කියන්නේ මේකේ? මේක නම් කරන්න ගියම් පිස්සු හැදෙනවා. හරි. select I want අහලා තියෙන question ටික නම් ලේසි ඒ අවුරුද්දේ. select from one the following valid class names that can be seen in the table given. ආපු චූටි ළමයිට කියන්න පුළුවන්. So J button is a class. J label is a class. J text field is a class, but these are variable names. So the answers are A, B, C. 31 A, B, C. 32. Select from among the following the valid object names that can be seen in the table. So these are the classes. Object names are D and E. Text are label කියලා object names තියෙනවා ඉතින් අනිවාර්යෙන්. හරි. The text label හරි. Answers are D and E. D and E. 33. Select from among the following the valid user-defined methods shown in the table given. User-defined methods. User ලියපු methods මොනවාද? අහන method තියෙනවා. Add is not a user-defined method. That is a method in the Java, that particular class. User-defined methods තියෙනවා. Actually, there are no user-defined methods. Maybe public X. Maybe user-defined method එක. EX කියන method එක. ඒක හැබැයි extend හැබැයි construct එකක් නේද? It's not a method actually, it's a constructor. සමහරට මෙයා ගන්න නැත්තේ මේ JDK එකේ තියෙන methods වෙන්නේ නැති. Because there are no user-defined methods actually in this code, but maybe they have taken add. Right, add. What else? Yeah, only add. So maybe they have taken add as the user-defined methods. සමහරට මේක user එකේ class එකේ තියෙන method එකක් කියලා අරගන්න. So then we'll go for add. Okay. I'll go for A. 33. E තරම් තියෙනවා. set layout කියලා method එකක් තියෙනවද? මම දැක්කේ නෑ එක. Yes. But this is not a method, this is a constructor. No, set layout. Yes. Right. So this is again not user-defined method. This is JDK specific method, but anyway, those are methods. Question එක හරියට අහලා නැහැ. හැබැයි උත්තර දෙක එහෙම බැලුවොත් හරි. Set layout add. හැබැයි මේ user-defined method නම් නෙමෙයි. Those are methods in Java built-in classes like JFrame and so on. Okay, J component. So therefore, question is not very correct. But anyway, the answers what they have taken is methods in general methods. Select from one the following valid constructor methods illustrated in the table. So obviously J button, J label. These are just class names. Constructor na innona. Flow layout. Flow layout object එකක් තමයි හදන්නේ. Answers are B, D, E. B, D, E. Yes, B, D, E. දැන් අහනවා මෙන්න ඔන්න වට්ටෝරු question එක අහලා තියෙනවා. මෙන්න මේගොල්ලෝ output එක. So that means you are expecting something like a text box ද නැත්නම් text area ද? Java කියලා තියෙන්න ඕනේ ඒක ඇතුලේ. Yeah, J text field එකක් හදන්න ඕනේ නා. ඉතින් Java කියලා දාලා හරි දැන් අහනවා ඕගොල්ලන්ගෙන් මේ මොන විදියට කෝඩ් ලියවමද අහනවා මේක හැදෙන්නේ. දැන් ඔයා මේක නම් කරන්නේ අන්තිමටම කරන්න ඔයාලට. හරි කරන්න මෙලෝඩියක් නැත්තම් විතරක් කරන්න. දැන් ඔයා බලන්න ඕන 1 13 14 කියන කෝඩ් ටික ලියලා ඒ කෝඩ් එකෙන් එනවද මේ අවුට්පුට් එක කියලා. It's very time consuming. It's like a ragging for you. ඊට පස්සේ මේ කෝඩ් එක ලියලා බලන්න. ඒ කෝඩ් එකෙන් එනවාද කියලා. හරි. අපි කරන්නේ swing programming. ඒක ඔයගොල්ලෝ කරන්නේ මේක නම් මම එක්සෑම් එකට ගියොත් මම නම් කරන්නේ නැහැ. මට නම් මේ ලකුණු ටික එයාටම තියාගන්න කියලා. ඔයාලා ලියලා ඉන්න මට වෙලාවක් නැහැ. But anyway, you are not me. Right. So yeah, for write the 16, 15 and බලන්න මේ කෝඩ් එක මේක හදනවා කියලා. ඔගේ ඇති දෙයක් නැහැ. හරි මේක කරන්න හරි කම්මැලි. Next one. එතනටම තමයි text field එකක් එන්න ඕන. හරි මෙතනට එන්න ඕන එතකොට නෑ. text field එකක් එන්න ඕන දෙවෙනි එකට නේද? I think this is a text field. This is the label. Yeah, this should be the label. Okay, label එකක් හදලා තියෙනවා. maybe 15 එක the label එකක් එන්න කලින් එකට දෙවෙනි එකට තමයි text field එකක් එන්න. because this is the text field. අර කෝඩ් එකමයි text field කියලා මාරු වෙන්න ඕන line එක. හරි. ඊළඟට උතන බටන් එක දාන්න. එකම කෝඩ් එකේ මැදට බටන් එක එන්න ඕන. Right. So next one. Consider the following program written in Java programming language. Select from one the following the changes required into the program for the event handling in Java. If the software engineer uses button instead of checkbox in the program. Button එකක් විදිහට checkbox එකක් පාවිච්චි කරන්න. checkbox එක නම් අපේ event handler එක වෙනස් වෙන්න ඕන. හරි. Where is the event handler code? Right. So here the event handling is not yet done. Okay. Yeah. Add item listener is there. Right. Add item listener anonymously implemented. So it must be button instead of checkbox. So therefore, item listener will become action listener. Add item listener will become add action listener. Not mouse listener. Yeah, maybe add item listener become add action listener. Then item event become action event. So therefore, answer is C. But action listener. Answer is C. Right. 39 answer is C. C. 40. Select from one the following the valid method which are related to JFrame class. Set visible තියුණ මතකයි නේද? Set visible, set title, set default close operation, set size. I don't think there's something called set size. එහෙම එකක් නම් මතක නෑ මට. අනිත් ඒවා නම් අපි පාවිච්චි කරා. Okay. So I'll go for everything other than D. Yes, everything other than D. So 2020 we did, 2021 we did, 2022 also we did. Okay. Java FX අර අනිත් මුළු සිලබස් එකම කරලා තියෙන ප්‍රෝග්‍රෑමින් වල. හරි මුළු සිලබස් එකම කරලා තියෙන්නේ Java FX අර. මොකද FX කරන්න ගියොත් එහෙම දවස් ගාණක් යනවා. හරි. මුළු BIT ඉතිහාසෙම FX වලින් එක question එක ඇවිල්ලා දින්නවා. හැබැයි FX note එක කියව ගන්න. So the Java FX note is there, but I'm not going to do it because it takes a lot of time. Okay. So, but just rush through the Java FX note, UCSC note to our note to both. Yeah, Java FX our note is also there. The UCSC note is also there. Just go through it. මට ගිය පාර රෙකෝඩින් එක හම්බුනොත් දාන්න මට හොයාගන්න බැන්නා ගිය අවුරුදු BS කට්ටියගේ රෙකෝඩින් එක. ඔකේ ඒගොල්ලන්ට කරා. හැබැයි මම ඒක රෙකෝඩ් කරලා නැහැ. හරි මොකක් හරි ප්‍රශ්නයක් වෙලා තියෙනවා. හරි මම බලන්න. තියුණොත් දෙන්න රෙකෝඩින් එකත්. It's pretty much like swing, but so there are few more things to be done. Okay. Right. So programming වල මොනවා හරි ප්‍රශ්න තියෙනවද වෙන? programming subject? Anything that you want me to discuss? Any specific questions? Okay, so let's make it an open discussion. Right. So do you have any question related to programming that you want to get things clarified? Object-oriented, structured programming, collections, exception handling, any specific questions? මට මෙන්න මේකේ මෙන්න මෙතන කතන්දරේ තාම පැහැදිලි මදි කියලා. හැබැයි මේ වගේ ප්‍රශ්නයක් අහන්නත් අර්ථ අවබෝධයක් තියෙනවා. ප්‍රශ්න අහන්න බෑ නේද? ඒ වගේ ස්පෙસિෆික් ප්‍රශ්න අහන්න බෑ. ඔයාලට තේරෙන්නේ නැතුව සබ්ජෙක්ට් එක. සබ්ජෙක්ට් එක තේරෙන අයට තමයි සෑහෙන ප්‍රශ්න තියෙන්නේ. ඒ සබ්ජෙක්ට් එක තේරෙනවා, තේරුම් ගන්න උත්සාහ කරනවා. එතකොට ප්‍රශ්න ඇති වෙනවා. හැබැයි ඒගොල්ලන්ට ඇති වෙන්නේ ස්පෙસિෆික් ප්‍රශ්න ඇති වෙන්නේ. ඉන් ජෙනරල් ත්‍රෙඩ් තේරෙන්නේ නැහැ. ඉන් ජෙනරල් ඔබ්ජෙක්ට් ඔරියන්ටඩ් තේරෙන්නේ නැහැ කියලා. එතකොට ඒගොල්ලන්ට ඉතින් මේ වෙලාව උදව් කරන්න බෑනේ මට. ඒගොල්ලන්ට සති ගාණක් අරගෙන කරානේ. Right. So we'll take 10 minutes break. ඒ විනාඩි 10 ඇතුළත ඔයගොල්ලන්ගේ තියෙන ප්‍රශ්න තියෙනවා නම් කතා chat එකට දාන්න නැත්නම් කතා කරන්න ඕන. break එකෙන් පස්සේ. එහෙම නැත්නම් ඉතින් අපි තව past few question ටිකක් තමයි කරන්න තියෙන්නේ. හරි. මොකද අපිට හවස ක්ලාස් එකේ කරන්න ඕන මේ latches. So latches මේ flip flops. සමහරවිට flip flops වලින් question එකක් දෙයක් එනවනේ. හරි. හවස ක්ලාස් එකට අපි flip flops ගමු. So therefore, I want you to ask all these questions you are having. Right. So we'll be starting at 10 to 30. Make sure you ask all the questions. Okay. Information system, sorry, programming and maths. So we'll start at 10:30. Okay, so let's continue. Should developer prefer to use check exception for recoverable conditions and runtime exceptions for programming errors, or use uncheck exceptions universally? Yeah, it depends. So there's a debate whether check exceptions are good or bad. So some developers, or some actually not, it's not something that individually someone can take that decision. That is something you have to take that decision as a team when you are doing development as a team. Usually, checked exception force you to catch those exception. Therefore, developer is forced to catch that exception. But if it is runtime exception, it is optional. So what happens is sometimes when it is optional, sometimes developers tend to forget catching those exceptions. Right? So they tend to forget catching those exceptions. So therefore, sometimes you forget in the when when it goes to the production time only, all of a sudden those errors are coming because the developer has not checked the exception. So the basic idea is if it is very critical, make it check exception. If it is not critical, make it runtime exception. But make sure the developers are professionals, they are very serious, and even though it is not forced, they have to look for those possibilities and catch it, because if it is unchecked exception, uh, catching is optional. So therefore, more responsibility goes to the developer when it comes to catching check exceptions. Okay. Sorry, unchecked exceptions. But if it is a check exception, developers are forced. So therefore, too much of check exception is also bad. Too much of unchecked exception is also bad. So you have to find out, you have to decide, it's a critical situation, let's make it check exception so that the developers always catch it. But if it is not a very critical situation, make it runtime exception so that developers catch it only when it is required. Otherwise, unnecessarily, you have catch blocks and you don't do anything in that catch block as well. Okay. Right. So I think with these questions we discuss in the class itself, right? Yeah. So same set of questions. So those questions either we have already discussed, or we have discussed it in the past paper, or we have discussed it in the module arithmetic topic. So we don't want to do the same question twice. Okay. Just give me 1 minute. Okay, sorry for that. Okay, right. 2019 last three questions. 2019 last three questions. Let me double check 2019 last three questions. Right. So last three question today we did. Okay. So we did the last three questions today itself. Right. So we'll do some random past paper questions from programming, some random questions. Okay. Or we can do the computer system latches. Okay. Shall we do the latches then? Okay. We'll do the latches and finish it. So then the computer system syllabus is also finished. Okay. Then evening we can take some questions, programming, computer system or whatever. Okay. Right. So let's finish the computer system subject. Okay. So then your mind is also good that syllabus is fully done. But they have asked only some years just one question, some years two questions. But remember, understanding flip-flop is the hardest, one of the hardest thing in the digital electronic. So therefore, it's good if you can understand flip-flops. Basically, your confidence is super high. Okay, it's just like if you can understand sequence and series, modular arithmetic, your confidence in maths is very high. So similarly, if you can understand flip-flop latches, your confidence in computer system subject is very high. So those are also very important thing, your confidence. Okay. So therefore, let's finish the flip-flop today itself. So in the morning session itself. Okay. So then the syllabus is all fully done. Right. Boolean algebra and digital circuit. Okay, so I'll just take 10 minutes to do a quick revision and then straight away go into latch flip-flops and finish it. Okay. Right. So remember we first discussed the SR latch. Right. SR latch. SR latch is basically a set reset latch where when S equals 0, R equal 1, it is set. Sorry, when S equal 1, R equals 0, it is set. Then when R equal R equal 1, S equals 0, reset. 0, 0 means memory. And 1, 1 is the invalid scenario. Right? 1, 1 is the invalid scenario. So that is how SR latch work. You can create SR latch working using two NOR gates. Two NOR gates. Right? So that is what SR latch is. Right? So any question on SR latch? Because now we want to finish the subject. Okay. So you must have enough seriousness, thinking capacity, enough patience to understand how the SR latch work. Okay. Right. So then we discuss gated SR latch. So what is the advantage of gated SR latch? So we have enable signal. When enable is 0, your latch is locked. Right. When the enable is 0, it just remember whatever the value. It just remember whatever the value. Okay. So therefore, that is another way of memory. So rather than R equals 0, S equals 0, you can use enable to take it to memory. That is enable is 0. Right. Enable is 0. Because when enable is 0, it doesn't matter what happened to your S and R. So likewise, you have to explain it. Just give me 1 minute. Right. So when your enable is 0, always these are 0. It doesn't matter what happened to S and R. Even when S and R both are 1, 0.1 is 0. 0.1 is 0. So therefore, if you get some stray signals, හිතුවා මේවා වෙන වෙන සිග්නල් එන්න පුළුවන්. ඒ සිග්නල් මොනවාවත් වැඩක් නැහැ. When enable is 0, it is just remembering the previous value. It just remember the previous value. Okay. So that is the advantage of enable. එකත් තේරුණාද? එතනත් මොනවාරි ප්‍රශ්නයක් තියෙනවද? So do you have any doubts about the role of the enable? අන්න ඒ ඉස්සරහට යන්න ඕන අපි ටික ටික. No, because your task is not collecting doubts, your task is collecting confidence. Okay, right. So gated SR latch. So then you should be able to understand this kind of a timing diagram. Remember, when enable is enabled, of course your Q will follow S. When S is 1, R is 0, Q will be 1, right? When both are 0, it retains the previous value, and so on, right? So on. Right? Now this is S become 1, R becomes 0, therefore it is set. Now again, both S and R become 0, but it's memory now, because enable is 1. Now again set, again 1, still it's 1. But now only you can say R is 1, S equals 0, now it is reset. And until S become 1, R 0, it is, now it is, after this point, it is memory. After this point, it is memory. මේ point එක පස්සේ memory එක විදියට තියෙන්නේ R reset වෙච්ච value එක මතක තියාගෙන ඉන්නවා. So then again it set. Now again memory. R0 is 0. Now again reset. Again memory. Again reset. Reset කියන්නේ තාමත් reset ම තමයි. And memory. So do you have any doubt about how this diagram is built? How this diagram is built? Any doubt? Yes or no? No doubts? Doubts තියෙනවා කියනවා මට පුළුවන් ආයෙ explain කරන්න. හැබැයි ඔයා හරියට question අහනවා. හොඳට මතක කෙනෙක් ඉගෙන ගන්න ඕන නම් එයාට specific question අහන්න පුළුවන් වෙනවා. හරි. ඉගෙන ගන්න ඇයට නිතර ප්‍රශ්න තියෙනවා. හැබැයි ඒගොල්ලෝ අහන්නේ specific question එක. මෙන්න මෙතන මෙන්න මේ චුට්ට මට තේරෙන්නේ නැහැ කියලා කියන්නේ. තව කොටසක් ඉන්නවා මෙලෝ මගුලක් තේරෙන්නේ නැහැ කියලා කියන කට්ටිය. ඒතකොට ඒගොල්ලන්ට ආයි මුලින් ඉඳලා subject එක ගන්නන්න බෑනේ. ඒකට නොතේරෙනකොට නොතේරෙන තැනට අක් ගාලා කියනවනේ මෙතන තේරෙන්නේ නැහැ. So then we can fix it and move forward. Then again you have issue, fix it, you move forward. Again you have issue, you fix it, you move forward. අන්න ඒකට තමයි වැඩ ඉස්සරහට යන කට්ටිය. සමහරු මේ අපි ඉන්නේ මේ හරිය, සමහරු මේ හරිය හිර වෙලා ඉන්නේ. ඒතකොට ඒ හරිය කතා කරන්න තියෙන මේ වෙලාවේ. Right. So that is what gated SR latch is. ඔන්න දැන් enable එක disable වෙලා තියෙද්දි මොකද වෙන්නේ? අපිට මේ කතන්දරේ ඕන flip flop එක තේරුම් ගන්න. Right. So when enable is disabled, it is memory. Now remember set. Right. So at the beginning, let's assume both Q is 0. Now enable is disabled. එහෙනම් ඒ 0 කියන එක තමයි තාම මතක. Still it is 0. Right. Still enable is 0 කියන්නේ අර කලින් පටන් ගත්තේ මොකද්ද ඒකම තමයි තියෙන්නේ. Now enable. But still S and R are both 0. That means just remember memory. But now S become 1. S1 R 0. So therefore it is now set. And enable is enable. And while enable is enable, now R become 1, S become 0. Therefore it is reset. Now enable is enable. Right? So therefore now it's remembered because now both S and R are 0, but enable is 0. That means whatever the current value is remembered. Now enable is disabled. Disable කිව්වා කියන්නේ තියෙන value එක මෙයාගේ enable වෙනකන් ආයෙ වෙනස් වෙන්න විදියක් නැහැ. Because now it is memory. But now enable, but still S and R are 0. Now S become 1, enable is enable, so therefore now it's set. Now both are 0, but any still memory. Now disable කරනකොට මෙතන මොනවාද තියුනේ ආයෙ enable වෙනකන් මොකද වෙනස් වෙන්නේ. Okay. So that is how SR latch with enable work. Right. So any question on this? Any question on this? මොකද ඔතනින් එහාට තමයි ද ඊළඟට යන්න තියෙන්නේ. Flip flops. Any question? No. Question no. Question no. 100% understood. Okay, right. That's fine. So then we discuss S bar latch. So S bar latch is identical to behavior of the SR latch. Only thing is we use NAND gates rather than no gates. Right? Rather than no gates, we use two NAND gates. මතකනේ කලින් අපි මේකට කිව්ව කොහමද? So this is Q, this is Q dash, this is R, this is S. මතකනේ R දුන්න තියෙන්නේ. Rather than R, we call it S bar. මොකද R කියන්නේ S bar ම තමයි. Rather than S, we call it R bar. මොකද වෙන නමක් දෙන්න ඕන නම්. Right. The truth table is the same. Because remember, S bar is R bar is S. When S is 1 or R bar is 1 set. When R is 1 or S bar is 1 reset. But there's a small thing now. When earlier, when R0, S0 is the memory. But now in S bar latch, S bar 1, R bar 1 or S1, R1 is the memory. Earlier, 1, 1 is the invalid situation. Now 0, 0 is the invalid situation. And මේ දෙකම 0 වුණොත් තමයි invalid වෙන්නේ. ඇයි invalid වෙන්නේ කියලා කියන්න පුළුවන්. When this is 0, 0 something, 0 and something is 0, that bar is 1. So both are 1. ඔක්කොම දෙකම 1 වෙනවා. දෙකම 1 වෙනවා කියන්නේ මේක invalid. ඔක අර කියුනේ O gate වල. Right. Any questions? Same switch and R, sir, can we use S name? What is mean by S name switch? S name switch කිව්වෙ මොකටද යා? question එක තාම switch name. SC switch can we use switch name? And still the question is not clear to me. තාම question එක නම් ඔලුවට ආවේ නැහැ. S name switch and R reset retain. Still not. The question is not clear. Question එක පොඩ්ඩක් කටින් හරි කිව්වොත් මට තේරුම් ගන්න ලේසි වෙයි. නැත්නම් තාම ඔලුවට ගියේ නැහැ. තාම question එක කෑල්ලයි දිනවා ඔලු හිතේ තියෙන එක මට කියව ගන්න බෑ. ඔයා ලියන ටිකක් විතර මට තේරෙන්නේ. හරි. ඔයා ලියන ටිකක් කතා කරන ටිකක් විතර මට ඔලුවට එන්නේ. ඔයාගේ හිතේ තමයි question එක ඉතුරු කෑල්ල ඇත්තේ තාම. Right. I remember S bar is same as R. R bar is same as S. So now set is S bar 1. Maybe you can reword the question. Maybe I can again try. So therefore now remember S bar 1 is reset. R bar 1 is, because that is S, that is set. But retain is 1, 1. That is the difference. And now 0, 0 is invalid. And for this one also you can have enable. Enable එකක් දාන්න පුළුවන් මෙයාට. Okay, දැන් ඔයාලට compare කරන්න පුළුවන් SR latch එකයි S bar latch එකයි. Okay. Right. So this is called gated SR latch. Now we have the enable. Enable එක නිකන් දාන්න බෑ මේක අරක වගේ. Right. So remember in normal SR latch, enable is just two AND gates. ඒක enable එකත් එක්කයි මේක enable එකත් එක්කයි බලන්න ඕන. හරි. ඒක නිකන් AND gate දෙකක් දැම්මේ. මේක දාන්න මොකද්ද? NAND gates. Right? NAND gates. කලින් එකේ තියෙන්නේ මොකද්ද? Two NOR gates here, two AND gates here. Now here also we need two NAND gates. Now when enable is 0, it is memory. On අනිත් පැත්ත දැන්. Normal SR latch, when enable is 1, it's a normal thing. When enable is 0, it is memory or the locked. මෙයාගේ enable is 1, invalid. So sorry, enable is 1 is the normal scenario again. When enable is 0, retain. So no, it's the same, right? It is the same. Right? All latch එකේ වගේම තමයි. When enable is 0, memory. මෙයා 0 වෙද්දි මේවට මොනවා ආවත් අපිට ප්‍රශ්නයක් නැහැ. මෙයා memory. හැබැයි enable 1 වුණාම මෙයා සාමාන්‍ය latch එකක් විදිහට වැඩ කරනවා. ඒ කියන්නේ මේවට respond කරනවා. For example, what happens when enable is 0? 0 dot something is 0. 0 bar is 1. Enable is 0 means මේක මොනවා වුණා 0 dot something is 0, that bar is 1. ඔය දෙකම 1 වෙනවා. දෙකම 1 කියන්නේ මොකද්ද? දෙකම 1 කියන්නේ memory. So that is why we say 0 is memory. Okay, 0 is memory. 0 කියන්නේ memory. Because මේක 0 කියන්නේ මේ දෙකට 1 1 එනවා. මේ දෙකට 1 1 එනවා කියන්නේ SR දෙකට 1 1 එනවා කියන්නේ memory. මෙතන පොඩි note එකේ පොඩි අවුලක් තියෙනවා මට පේන්නේ නේද? මෙතන 1 1 invalid නෙමෙයි 1 1 memory වෙන්න ඕනේ. මට පේන්නේ note එකේ පොඩි අවුලක් තියෙනවා. මතකයි නේද? 1 1 is memory. හරි 1 1 is memory. S bar වල මෙන්න මේ slide එකේ පොඩි වැරද්දක් තියෙනවා. සමහරවිට ඔයගොල්ලෝ confuse වෙන්නේ නැති. So this 1 1 is මේ හැබැයි SR එකට ඇඳලා තියෙන්නේ එක ඇඳලා තියෙන්නේ. ඇත්තට මේක S bar එකට අඳින්න දෙන්නේ අපිට. S bar වලට SR කියලා දාපුවම අවුලක් නැහැ. But anyway it should have been presented slightly differently. Okay. But remember when enable is 0 it is memory or it's locked. When enable is 1 it act like a normal latch, normal S bar latch. Okay. Right. So then we discuss the D latch. D latch එකේ කරපු එකම වැඩේ මොකද්ද? අපි R වෙනුවට දුන්න S one not කළා. Right? Rather than R we use the S bar. So remember this is R, this is S, and this is my S, this is my S. But rather than R, so earlier we had two S and R, but now your R is S bar. May R is then appear S bar. Because when you set S is 1, R is 0, when reset, R is 1, S is 0. කොහොමද අපි set කරද්දි reset කරද්දි අනිත් එක කරන්න එන්න ඕන අරයක අනිත් එක. So therefore that is fine, right? That is fine. So therefore only thing is there's nothing called memory now. Because in this arrangement, there's no way you can get both 0. Right? Both 0. And also you can't get both 1. So anyway, that is fine because both 1 is invalid. So therefore, when you set it, until you reset it, it is set. So then you reset. So then until you set it, it is reset. So therefore, that is also very simple latch. Very simple latch. The memory key එකක් වෙනව නැහැ. Set D විතරයි තියෙන්නේ. When D is 1, Q is 1, Q bar 0. When D is 0, Q is 0, Q bar is 1. So there's nothing called memory. Set කරාම set කරපු එක දිගටම තියෙනවා. High reset කරනවා. Reset කරාම දිගටම reset එකේ තියෙනවා set කරනවා. Right. Any question on that? Anyway, D latch is the easiest one to understand. D latch is the easiest one to understand. හැබැයි stray signals දිනනවා ඉතින් නේද මේක වැරදිලා හරි වෙනස් වුණොත් මොකද වෙන්නේ 1 එක 0 වුණොත් මේක මාරු වෙනවා ටක් ගන්න මේක මාරු වෙනවා but now we have only one input. Any question on that? No. So you can do it for D latch with no gates or D latch with NAND gates. NAND gates වලින් තියෙනවත් ඒකම කරන්න පුළුවන්. So this is D latch with NAND gates. Again, when D is 1, Q is 1. When D is 0, Q is 0. D is 0, Q is 0. දැන් ඒකම කාටම බලන්න පුළුවන් නේ. When D is 1, what happens? This is 1, so this is 1, this is 0. 1 by 0. Remember, this is my R or S bar. And this is my S or R bar. Okay. Then truth table එක බලන්න පුළුවන්. එකක් හරි 1 වුණොත් එහෙනම් මොකද වෙන්නේ කියලා. එකක් හරි 1 වෙච්ච ගමන් sorry එකක් හරි 0 වෙච්ච ගමන් මේක 1 වෙනවා. Because 0 dot something is 0, that bar is 1. අන්න මේ පටන් ගන්න explain කරගන්න. So therefore again Q follows D. D ට මොකද කරන්නේ? Q ත් එක වෙනවා. D එක වෙද්දි Q එකයි. D 0 වෙද්දි Q0. Again, follows D in D latch, whether it's no gates D latch or NAND gate D latch, Q follows D. So then, of course, you can make it gated because make it gated now. Gated නැත්තේ මේ කොයි එක ගත්තා Q වැරදිලා හරි වෙනස් වුණොත් sorry D වැරදිලා හරි වෙනස් වුණොත් එimhe Q වෙනස් වෙනවා. Right. So therefore, to make it gated D latch, we can use this arrangement. Right. So කලින් එකම තමයි කලින් gated SR latch එකම තමයි. හැබැයි ඉතින් මේක note කරලා දෙනවා මෙයාට direct එක දෙනවා. ඒ no gates වලින් ගියා. එහෙම නැත්නම් අපිට පුළුවන් NAND gates වලින් ගියපු S bar R bar latch එක අරන් gated D latch එකක් හදාගන්න. This is from no gate, this is from NAND gate. මතක නේද NAND gate හතරක් ගත්තා. ඒතකොට මේක මෙයාව note කරලා දෙන්නවා. And now we have the enable. So now we have D latch with enable made using no gates or made using NAND gates. NAND gates වලින් හැදුවොත් එහෙම හතරම NAND gate. No gates වලින් හැදුවොත් එහෙම දෙකක් no gates අනිත් දෙක AND gates. හරි. ඒක D කරාම මොකද වෙන්නේ? අරයාගේ input එක invert කරලා මෙයාට දෙනවා. Right. Any question? Any question? So this is one of D gate using all NAND gates and here also NAND, or you can have here two no gates, here two AND gates. Okay. So this is no. So මේක තමයි අපි දැන් කතා කරේ හරි. හැබැයි ඔක තව විදිහකට හදන්න පුළුවන්. මෙන්න මෙහෙමත් හදුවට වැරද්දක් නැහැ. So this is what we discussed, right? Gated S bar bar latch. So there's an alternative way, that is rather than you give this one without using NOT gate, you can connect like this also. So there you have the D and enable, but we don't use NOT gate, rather you connect this output to here. Right, this output to here. NOT කළා ගත්තා වෙනකොට මෙයා වර්ගෙන් දැම්මත් වැරද්දක් නැහැ. Right? Same result is there. But anyway, don't worry too much about that. But anyway, if you see this kind of circuit, this is equivalent to this kind of a S bar, sorry, D latch. Here also you have only one input signal and enable signal. හරි. ඔන්න ඔතනින් තමයි නැවතුනේ. ඔතනින් තමයි නැවතුනේ. right. ඊට පස්සේ ඔයාලට මෙන්න මේ වගේ එකක් ඇඳ ගන්න පුළුවන් වෙනවා. මේක හරියම ලේසියි දැන්. හරි. කොහොමද මේක තේරුම් ගන්නේ? So this is a D latch with enable, and this is Q and Q bar. When D is 1, Q is 1. When D is 0, Q is 0. But that happens only when enable is 1. When enable is 0, it just retains the previous value. Simple as that. Enable 0 නම් එයා කලින් value එක තියාගෙන ඉන්නවා memory එකේ. Right. Now you can see D is 0. Enable is enable. So therefore your Q is 0. Right. D0 can Q0. Now D is 1 and of course enable. So therefore now your Q is also 1. Q is also 1. Now again D0 enable is enable. So therefore your Q is also going down. Q is also going down. Now again D1. So that means your enable is enable. Your D goes up. Now again D goes down. Q goes down. Right. Q goes down. Right. Now again still enable is enable. Now again D goes up to this point. Up to this point. Now enable is disabled. You can enable එක enable වෙනකන් දැන්ට තියෙන value එක retain කරන්න ඕන. එන දිගට මේක තමයි. ඔය කෝක අතරේ මොනවා වුණත් වැඩක් නැහැ. Because now it is enable is disabled. Whatever the current value is retained. Now again enable is enable. Now D is 0. ඒ වෙද්දි D 0 වෙලා තියෙන. එහෙනම් ටක් ගාලා මෙයා 0 වෙනවා. But again now enable is enable. D goes up. Q follows D. Now Q goes down, so that means your D also going down. But the enable is enabled. Now enable is disabled. I enable like enable and come memory. Now again, when the enable is enabled, D is up, so therefore your Q is up. Your Q is up. And still enable is enabled, so D down means Q goes down. On no graph. Right. So that should be your graph. Okay. So this should be your graph. Any question on that? So D is down, Q is down. Enable, when D goes up, Q goes up. When Q goes down, D goes down. When D goes up, Q goes up. When Q goes down, D goes down, because enable is enabled until this time. So here also D goes up, Q goes up. මෙයා මේ වෙලාවට එනකන් දැන් කෝකම තමයි තියන්නේ memory. මෙයා down වුණාට වැඩක් නැහැ because now in disable. So any question on that? මේ graph එක තේරිච්ච නැති කෙනෙක් ඉන්නවද? So when enable is enabled, Q follows D. When enable is disabled, whatever the current value is remembered. මෙතන තියච්ච value එක යා මෙතන ආයි enable වෙනකම් retain කරන් හිටියා. ඒ පාර ඔන්න දැක්කා D එයා දැන් D follow කරනවා. D1 හන්ද එයා 1 වෙනවා. ඕක තමයි තව චුට්ටකින් අපි flip flop කියලා කරන්නේ. මේ enable disable signal එක වෙනකොට අපි කියනවා මේකට clock signal එකක් දාමු කියලා. So if you have understood up to this point, right? So I don't know whether you can understand the flip flop, but still you are good. ඊළඟ round එකට තාම selected. ඊළඟ round එකෙන් එළියට ඇවිත් දන්නේ නැහැ. ඔයාගේ task එක තමයි එහෙම round වලින් එළියට යන්න නැතුව ඉන්න එක. Right. So since no questions, now we can go to the flip flops. දැන් අපිට flip flops කතා කරන්න පුළුවන්. කතාව ඉවර කරන්න පුළුවන්. Right. What is a flip flop? So we will look at what is flip flop gradually. Okay. So far what we discussed are latches and gated latches. So what are the advantages of gated latches over latches? Anyone? Latch එකට වඩා gated latch එකේ තියෙන වාසිය මොකක්ද? Anyone? ඒකේ වාසිය දන්නේ නැත්නම් මේ flip flop කරන්න බෑ. ඒකයි අහන්නේ. ඒ වාසිය තවත් ලොකු වාසියක් කරගන්නයි හදන්නේ. So when we have enable, disable or enable signal, we have a way to lock it. Enable එක disable කරාට පස්සේ මේ SR වලට මොනවා ආවත් එයා ගණන් ගන්න නැහැ කලින් එක මතක තියාගන්න. ඒක හරියට අර ඔයාලට මොකක් හරි මතක තියාගන්න කියනවා. ඊට පස්සේ කියනවා වෙන කවුරුත් කියනවා ගණන් ගන්න එපා මම මේ කියපු එක මතක තියාගෙන ඉන්න ඕන. මං එනකන් ආවේ. එතකොට ඔයා කරන්නේ මොකද? අනිත් අය කියන මොකකටවත් කන් දෙන්නේ නැතුව අර කලින් එක මතක තියාගෙන ඔහේ ඉන්නවා. ඒකට ආ රෙස්පොන්ඩ් කරන්නේ නැහැ. අර සමහර කෙනෙක් මම කන් ඕෆ් කරන් ඉන්නේ කියලා. මම කන් ඕෆ් කරන් ඉන්නේ කියලා. අන්න ඒ කන් ඕෆ් කරන් ඔයා කලින් අවසාන වශයෙන් තිබ්බ එක මතක තියාගෙන ඉන්නවා. ඒකට ඒ අතරතුර වෙන හුටපට සද්දපත් දැවුනට ඔයාගේ මනස වෙනස් වෙන්නේ නැහැ. ඔයාට රෙස්පොන්ඩ් කරන්නේ නැහැ. So that is what enable signal is doing. Right. That is what enable signal is doing. Yeah. Gray නෙමෙයි පාවිච්චි කරන වචනේ stray. Right. සමහරට ඔයගොල්ලෝ ඇහෙන්නේ gray කියලා. මගේ pronunciation එක stray. Stray කියන්නේ දඩාවතේ යන. Stray dogs කියන්නේ. Stray dogs ලා කියන්නේ මොකද? දඩාවතේ යන බල්ලෝ. Stray signal කියන්නේ අපි හිතන්නේ නැති වෙලාවට එකපාරට pulse එකක් එන්න පුළුවන්. Okay. Yeah, independent of other inputs. That is also correct. අනිත් inputs වලට දැන් මෙයා independent. එයා ගණන් ගන්න නැහැ. Inputs එයා inputs වලට respond වෙන්නේ නැහැ. Right. So now let's look at gradually. Let's try to understand what is flip-flop is. First, we want to understand the clock signal. Then we want to understand the difference between level triggering and edge triggering. So then we want to build on few more concepts related to these. And finally, we want to understand what is JK flip-flop. Okay. Right. So what is mean by clock? Clock is something in your computer microprocessor that generate regular digital pulse. Regular, it's not regular analog pulse, no. Regular digital pulse or discrete 1-0 pulse. 1-0. Same amount of time 1, same amount of time 0. 1-0, 1-0, 1-0, and so on. So that device, that kind of a device is called a clock. And this is the clock signal. දැන් මෙතනදී එක තැනකදී තේරුම් නැත්නම් එතනදී කියනවා ටක් කරලා මෙතන තේරුම් නැහැ. මට මෙතන ඉස්සරහට යන්න බෑ. හරි. clock signal එක කියන්නේ මොකක්ද කියලා තේරෙනවද? Right, your clock signal has two levels. We call it low level, high level. Low level, high level. Low level, high level. And also, there's a point where all of a sudden it goes from low to high. So we call it leading edge, උඩට යන edge එක. And there's a point where all of a sudden it goes from high to low. ඒක එකපාරටම වෙන්න ඕනේ. ඒක තමයි discrete කියන්නේ. So that is called falling edge. දැන් ඔයගොල්ලෝ maths කියලා ඉගෙන ගන්නවා නේද මෙහෙම. y සමාන x වර්ගය, y සමාන x ධන 5 මේවට අපි කියන්නේ normal maths. Discrete maths කියලා જાතියක් තියෙනවා. Discrete maths වල මෙතන ඉඳලා මෙතන regularly යන්නේ නැහැ. මෙතන ඉඳලා එකපාරට මෙතනට පායනවා. මෙතනින් මෙතනට පායනවා. right? එහෙම යන්නේ එකපාරට මෙතනට පායනවා. එහෙමම තියවිලි වල එකපාරට මෙතනට පායනවා. එහෙමම තියවිලි එකපාරට මෙතනට පායනවා. So that is what discrete. So therefore this is a discrete signal. Okay? So you have the high level, low level, leading edge, falling edge. Okay? Leading edge, falling edge. So these are some usages of clock signal. So we can use the clock signal to synchronize set of components. What is mean by synchronize? Can you give me an example where in real world you have seen synchronization? In real world where you have seen the concept of synchronization. Synchronize කරනවා කියන්නේ ඔක්කොමලා එකට වැඩේ වෙන්න ඕන. Synchronize. දැන් synchronize කියන වචනේ තේරුම් නොගෙන මෙතනින් එහාට යන්න බෑ අපිට. I need a non-IT example, non-electronic example. ඔයගොල්ලෝ ඉස්කෝලේ යන කාලේ synchronization දැකලා තියෙනවා. ඉස්කෝලේ යන කාලේ නෙමෙයි. එක එක තැන් වලට ගියාම. time synchronize කරනවා යා. නෑ clock කතන්දරේ දැන් කියන්න බෑ ඔයාලට. මම අහන්නේ මෙන්න clock නොවන IT නොවන example එක. time කියවකම IT clock කියන වචනේ කොහොමද තියනවනේ. මට clock කියන වචනේ පාවිච්චි කරන්න බෑ දැන්. A person or thing that you have seen where things are getting synchronized. Yes, orchestra. So that is a very good answer. So that is superb answer. So that means you have seriously thought about what is synchronization. Orchestra. අර ඉන්නවනේ අර ඔපෙරාවක් අනම්මනම් කරද්දී අර එයා මුකුත් භාණ්ඩයක් වාදනය කරන්නේ එයා කව තියෙනවා මොකද දතේ තියෙනවා මොකද පොඩු කෑල්ලක් තියෙනවා එකෙන් නැත්නම් ඇඟිලි දෙක විතර අත් දෙක විතර පාවිච්චි කරලා එයා සින්ක්‍රොනයිස් කරලා දෙනවා. right? ඊළඟ මාර්ච් පාස් එක නම් මාර්ච් පාස් එක ඉස්සරහින් යන එක්කෙනා. ඒතකොට එයාගේ අත් යන විදිහට තමයි පිටිපස්සේ යනවා. That is synchronization. That is synchronization. So this clock signal can be used to synchronize your circuits. මොකද ඒවා හරියටම synchronize වුනේ නැත්නම් හරි 1 වලට තැන් වලට 0 ගිහලා 0 යන්න ඕන තැන්න 1 ගිහලා ඊට පස්සේ 5යි 8යි එකතු කරාම එන්නේ 3යි 6යි එකතු කරාම උත්තරේ. Right? So therefore these clock signals help you synchronize all the other pulses. Right? And of course it generates the basic pulse with the potential to generate other what 1 0 0 1 0 1 1 වගේ හදන්න කලින් ඉස්සර තියෙනවා 1 0 1 0. ඒතකොට ඒක හදලත් දෙනවා. ඊට අමතරව මේක හරියටම සින්ක්‍රොනයිස් කරන්න මෙයා මේ ටයිම් ગેප් වල. හරි ක්ලොක් එක. ඒතකොට ආට එක එක ටයිම් ગેප් වෙන්නේ නැහැ. හැම ඩිජිටල් සිග්නල් එකක්ම යන්නේ නැනෝ සෙකන්ඩ් එක නම් නැනෝ සෙකන්ඩ් එකයි මේ ગેප් එක. તો නැනෝ සෙකන්ඩ් දෙකයි කියන්නේ ඒක 1 ඒවා දෙකක් කියලා දාන්න. Right. So clock signal is acting as the enable. Right. Only අපිට clock signal එක enable කරන්න පාවිච්චි කරන්න පුළුවන්. Right. In two different ways. Remember, we already used the concept called enable. When enable is 1, now your say your D latch is responding. When D is high, Q is high. When D is low, Q is low. But when enable is 0, even though your D change, your Q doesn't change. Q is in the memory. So therefore we can use the clock. By then enable when time එකයි disable when time එකයි සමානයි. මේවයිදී enable, මේවයිදී disable. Enable, disable. Enable, disable. Okay, so that means 50% of the time enable. 50% of the time disable. 50% of the time your circuit is enable. Other 50% of the time, because this is other 50%. Your circuit is disabled. Okay. And මේ වගේ තැන්වලදී ඔයාගේ සිග්නල් වලට එයා රෙස්පොන්ඩ් කරන්නේ නැහැ. මොකද ඔයාගේ ක්ලොක් සිග්නල් එක තමයි enable විදිහට දීලා තියෙන්නේ. එයා 0 දැන්. මේ වගේ තැන්වලදී විතර රෙස්පොන්ඩ් කරන්නේ. But that is not good enough. Because only 50% of the time now your circuit is safe for the stray signals. Other 50% of the time your circuit is active. Okay. Right. So therefore we have two type of triggering mechanisms. Two type of triggering mechanisms. What is known as level triggering and edge triggering. දැන් ඔයාගේ ඊළඟ ටාස්ක් එක තමයි මොකද්ද මේ level triggering සහ edge triggering කියන එක තේරුම් ගන්න එක. So level triggering means trigger කරනවා කියන්නේ මොකද්ද? Can you give me an example where you have heard the word trigger? Trigger කරනවා කියන්නේ කොකා ගස්සනවා. නේද? අර පිස්තෝලයක් ගත්තොත් එහෙම තුවක්කුවක්. මෙන්න මෙතන තියෙන එකට අපි කියන්නේ මොකද්ද? trigger වෙනවා කියලා. trigger එක. මෙයා මේවා කරුවා එකපාරට තුවක්කුපත් වෙනවා. අපි කියන්නේ trigger the gun. Trigger the pistol. පිස්තෝලේ පත්තු කරා. කොකා ගස්සනවා කියන්නේ. So there are two type of triggering. Triggering කියන්නේ ඒ වෙලාවේ තමයි වැඩේ වෙන්නේ. One is level triggering, other one is edge triggering. So level triggering means the triggering happens in these levels. මෙන්න මේ තැන් වල තමයි trigger වෙන්නේ. Edge triggering means the triggering happens either this point or that point. මෙන්න මේ වගේ තැන් වල තමයි trigger වෙන්නේ. Right? So this is one type of triggering, edge triggering. This is the other type of triggering, level triggering. So we want to make sure that your circuit is most of the time lock. ගොඩක් වෙලාවට lock එකේ ඉන්න ඕනේ යා. Stray signals වල respond නොකර. හැබැයි trigger වෙන තැන් වල විතරක් එයා respond කරනවා. So in that sense edge triggering is better. මොකද ඒවා එහෙම වෙන්නේ බොහොම පොඩි වෙලාවයි. අනිත් හැමතිස්සෙම circuit එක lock state එකකදී ඉන්නේ. මේවට එයා respond කරන්නේ නැහැ. එයා respond කරන්නේ මෙන්න මේ point එකේදී, මේ point එකේදී, මේ point එකේදී, මේ point එකේදී, මේ point එකේදී. But if you go to edge triggering, your circuit respond to these situations. So that is almost all the time it is. If it is high level triggering, 50% of the time enable, 50% of the time disable. If it is low level triggering, again 50% of the time enable, other 50% of the time disable. But if you go for edge triggering, very short time periods circuits are enabled. All the other time, 99% 99 වගේම කාලයක් මේක disable lock වෙලා තියෙනවා. මේ වගේ චූටි nanoseconds වල තමයි trigger වෙන්නේ. Okay. So do you have a good understanding about what is triggering and level triggering versus edge triggering? So therefore level triggering we can subdivide into high level triggering and low level triggering. High level triggering means the circuit is enabled when the clock pulse is high. මෙන්න මේ වෙලාවවල circuit එක enable. In other times like this, circuit is disabled. So that means 50% of the time your circuit is enabled, other 50% of the time your circuit is disabled. මතකනේ enable 0 වුණාම circuit එක කලින්ග මතක තියාගෙන ඉන්නවා. එයා respond කරන්නේ අනිත් ඒවා. Okay. So if enabling is happening at the highest edge, then we call it high level triggering. අපි ඔක පෙන්නන්නේ clock signal එක කියලා ලියන මෙහෙම clock කියලා දාලා නිකන් ඉරක් අරිනවා. ඒ කියන්නේ මොකද්ද? මෙයා trigger වෙන්නේ මෙන්න මේ edge වල. මෙන්න මේ edge වල තමයි ආ enable. ඔය enable ම තමයි ආ. හැබැයි ආ enable මොන අවස්ථාවකද? clock එක 1 වෙද්දි. clock එක 0 වෙද්දි disable. So that is called high level triggering. This is the circuit symbol we use. Clock signal එක ඉරක් අදිනවා නේ clock කියලා ලියනවා. But if the enabling happens in low level, so that means the circuit is enabled in low levels, right? Low levels. So then we draw this symbol. ඉරක් ඇඳලා රවුමක් අහනවා. clock කියලා ලියනවා. ඒකට කියන්නේ නැහැ ගොඩක් වෙලාවට මෙහෙම symbol එකක් දැක්කොත් that means level triggering but low level. So this is where your circuit is enabled. This is where your circuit is disabled. Okay, low level triggering. And again 50% of the time it's enabled, other 50% of the time it is disabled because low level like not 50% of the time. But look at the two different symbols now. Okay. Right. So then the edge triggering. So remember level triggering is good, but that is still almost all that 50% of the time it is enabled, other 50% of the time only it is disabled. අපිට මේ disable වෙච්ච කාලේ වැඩි කරගන්න හදන්නේ නැහැ. So the solution is go for edge triggering. Again we have two edges, rising edge, falling edge. මෙහෙමනේ ඇවිල්ලා ඔහොම යන්නේ. So if the triggering happens only in the rising edge, we call it positive or rising edge triggering. Positive or rising edge triggering. So this is where your circuit is active, enable. Otherwise, it's memory. So this is the symbol we use. කලින් පාවිච්චි කරේ මෙහෙම ඉරක්, එහෙම නැත්නම් මෙහෙම එකක්. Positive edge, negative edge. But this is positive level, negative level. Now this is positive edge. This is positive edge. So positive edge is the one that triggers. But if it is a negative edge that trigger, we use something like this. Negative edge. Negative edge triggering. So triggering happens in falling edge. Falling edge. Okay, falling edge. So this edge is the edge that triggers the circuit. Now the edge triggering is better because Very rarely it is active. Most of the time, inactive, 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 inactive. When මේ චූටි වෙලාවේ active. මේ චූටි වෙලාවේ active ඒ negative edge trigger ඉන්න. positive edge trigger ඉන්න මෙන්න මේ චූටි වෙලාවේ මෙන්න මේ චූටි වෙලාවේ මෙන්න මේ චූටි වෙලාවල active. So just very tiny amount of time. Other time the circuit doesn't respond to stray signals. Because other times the circuit is disabled. Okay. Now we want to differentiate latch and flip-flop. So far what we discuss are latches. Remember we use latch without enable or with enable. Of course, without enable there is no safety, no locking. It's a very simple latch. But we can make it little bit safer by going for level triggering. මතක නේද? Enable signal එක 1 වුණාම එයා respond කරනවා. Enable signal එක 0 වුණාම එයා respond කරන්නේ. So that means level triggering. So latches are level triggered. Of course, you can either level triggered or there's no enable disable. Simply the latch is there. But if you use enable disable, it's level triggered because enable disable. Okay. But there's an alternative approach where triggering happens not at levels but at edges. So then you call it flip-flop. Flip-flop. So the advantage of flip-flop is most of the time your flip-flop is disabled. Only for very tiny periods, periodically, your flip-flop is enabled. Because we use edge triggering. Okay, we use edge triggering. Right, now what we have done is make එකපාර තේරුම් ගන්න බෑ මම පුළුවන් තරම් slowly කරන්නේ. Now let's assume that this is my D, this is a D latch, okay, D, not a D flip-flop. But we have enable, of course D latch can have enable, but now you can see that my enable is a regular clock pulse. My enable signal is a clock signal. And let's assume it's a positive edge, positive level trigger. එහෙනම් අපි පාවිච්චි කරන symbol එක මොකද්ද? නිකන් ඉරන්. Negative edge නම් මෙහෙම රවුමක් දාන්න. So this is a positive edge trigger. දැන් ඔයාලට පුළුවන් මේක තේරුම් ගන්න. Now enable is 0 means whatever the D value is there. D0 කියන්නේ Q0. Enable එක positive වෙනකන් එයා A එකෙම ඉන්නවා. Now all of a sudden enable is positive. දැන් මෙයා මේ D ට respond කරනවද? නැහැ. Why? Enable is negative. Positive, sorry, 0. Now enable is enable. Now all of a sudden it finds that D is positive. So D is 1 means Q must 1. D follows Q. Sorry, Q follows D. Then yeah, එකපාරට 1. It's enable. As long as D is 1, it is 1. Because it's enabled now, right? Now D becomes 0. D 0 now මෙයාත් 0 වෙනවා. මොකද enable එක enable. So now it is 0. Now you can see enable is 0. දැන් ඉතින් enable එක 1 වෙනකම් මෙයා වෙනස් වෙන්න දෙයක් නැහැ. එයා මේවට respond කරන්නේ නැහැ දැන් ආ. Yeah. Now again it's enable, but when enable Q is D is 0, so therefore anyway Q is 0, it doesn't change. Well, Q කොහොමද 0 නේ ඉන්නේ D0. Then only D's become 1, so Q also become 1. Right? So enable is enable. Now enable becomes 0, so that means until enable become 1, whatever the current value is there. Now again enable එනකොටම Q0 තියෙන යටක් ගාලා Q, sorry, D0 වෙලා තියෙන්නේ වෙලාවේ Q0 කරනවා. So no changes up to this point. Then of course it is disabled. Now it's enabled. Now D is plus 1. Sorry, D is positive. Therefore it goes up. And again it respond. Go down. Respond because now enable is enabled. Now it's again memory. ඒ අතරතුර මේ pulse එකට respond කරන්නේ නැහැ because that happens during the disable. And now again enable is 1, but anyway your D is 0. So therefore it continues. So any question? Any question on this one? Now you can see it's edge triggering, but it's a regular clock pulse. Sorry, not edge triggering, level triggering. And it's a positive level triggering, but that level is enable is a clock, but we use the positive level as the enable, negative level as the disable. So therefore 50% of the time your latch is enable, other 50% of the time it is disabled. That means it just retain whatever the value, it doesn't respond to your signals. And this is still a latch because it's level triggering, not edge triggering. Edge triggering වුණොත් තමයි flip flop වෙන්නේ. Right, what are the drawbacks of edge triggering? An edge lasts a long period. Actually 50% of the time your edge is there, therefore vulnerable for stray signals. දඩාවතේ යන සිග්නල් වලට තාම vulnerable. මොකද මෙයා දන්නේ නැහැ දඩාවතේ යන සිග්නල් එකක්ද කියලා. එයා ඒවට respond කරනවා 50% of the time. Right, now let's look at what is an edge trigger or how to make an edge trigger. මේක තේරුම් ගන්න ඊළඟට පොඩි ගේම් එකක් දෙන්න ඕනවා. පොඩ්ඩක් කල්පනා කරන්න, පොඩ්ඩක් සීරියස් වෙන්න වෙනවා. මොකද්ද මේ edge trigger එකක් හදාගන්නේ? මොකද්ද edge trigger එකක් කොහොමද හදාගන්නේ කියන එක ඉස්සෙල්ලා. Right, remember edge trigger can be either rising edge trigger or falling edge trigger. So it must trigger only if it's a rising edge trigger, only at this point it must be enable. Rise කරා. උඩට යන්න මේක. මෙන්න මේ නිමේෂයේ මෙන්න මේ මූවමන්ට් එකේ විතරයි මෙයා පල්ස් එකක් ගන්නවා. චූටි පල්ස් එකක් ගන්නවා. So can we build something like that? ඒ වගේ අපිට හදන්න පුළුවන්. පුළුවන්. Okay. Say this is my C signal, clock signal. Okay, this is my clock signal. And let's assume this is an AND gate. This is AND gate. And here we have NOT. Now what happens when clock is 1? This is 1. This is 0. 1.0 is 0. හොඳට අහගෙන මම කියන එක හරි. Then what happens when we make it 0? When we make it 0. Okay, let's move to the next page and look at it. Right. So now remember, let's start with 0. හොඳට අහගෙන මම කියන එක. Say this is 0. So this 0 is this 0 because this is the input. But this goes through the NOT gate. So therefore, when this is 0, this is 1. And we know that 0.1 is 0. So therefore, output is 0. Output is 0. Now let's assume we all of a sudden make it 1. අපි දැන් මේ ටිකක් වෙලා ගිහලා මොකද කරන්නේ පාට? 0 ගෙන් 1 එකට මාරු කරනවා. මෙන්න මේ සිටුේෂන් එකේ ඉන්නේ දැන්. clock එක ගන්න clock එක 0 ගෙන් 1 වලට මාරු වෙනවා. Now I am interested in this particular movement. මෙන්න මේ නිමේෂය ගැන කතා කරා. So now all of a sudden 0 become 1. හැබැයි ඒ වෙද්දි මෙතන තියෙන්නේ මොකද්ද 0. දැන් මොන එකපාරට මේක 1 වුණා. So when this is 1, this is 1. But remember, it takes little bit of time to go through this 1 through the gate and become 0. එකපාරට 0 වෙන්නේ නැහැ. මොකද මේක gate එකක්. Gate එකක් ඇතුලෙන් යන පොඩි delay එකක් තියෙනවා. හරි ඒක වෙනකන් හැබැයි but this is not going through a gate. මෙතන 1 වෙනකොට this become 1. But it will take little bit of time to make it 0. But until it becomes 0, of course, it will become 0 within few seconds, few nanoseconds. But until that time, the moment you make this 0 to 1, This is 1, but still this is 1 because still it has not come through this NOT gate. So that very tiny time period, both are 1. And we know that when both are 1, 1.1 is 1. But that is for very, very, very tiny period. Because in next movement, this 1 becomes 0. Because may not get a hara in the duty vela theory. A vela you are I 0. And we know that 1.0 is 0. So therefore, for very tiny period, there's a 1 like this. May 40 pulse 1 here. But again, it becomes 0. 0 තියෙදි කොහොමද 0 1 වෙල් කරපු වෙලාව විතර පොඩි පාසයක් ගියා හැබැයි ආයිමත් ඒක 0 වෙනවා දැන් මේක තියෙන්නේ 1 okay so what we need is that kind of a situation then what happens when you go from 1 to 0 then 1 ගෙන් අපි 0 කරොත් මොකද when this is 1 this is 1 and of course then stable situation yeah when this is 1 this is 0 1.0 is 0 so therefore this is 0 then අපි තුම එකපාරට මේව 0 කරනවා I'm looking at that movement ඒ කරපු වෙලාව තමයි ඒ නිමේෂය කතා කරන්නේ now of course when this is 0 this is 0 but remember before that it was 0 හැබැයි මෙයාට මේක හරහා එන්න තාම වෙලාවක් නැහැ right so therefore previously it was 0 there's a situation where 0.0 0.0 is 0 so therefore anyway it is 0 but after few nanoseconds this 0 become 1 because මේ delay එකක් තියෙන මේ not gate එක හරහා එන්න ඒ අතරතුරත් එයා 0ම තමයි now it become 1 of course 0.1 is 0 therefore it is 0 එහෙනම් මේක 1 වලින් 0 වලට යද්දි වෙනසක් නැහැ 0ම තමයි හැබැයි 0 වලින් 1 වලට යද්දි චූටි පල්ස් එකක් එනවා චූටි පල්ස් එකක් එනවා okay චූටි පල්ස් එකක් එනවා එහෙනම් අපි මෙයාට දීලා තියෙන්නේ මෙන්න මෙහෙම පල්ස් එකක් 0 වලින් 1ට යනවා 1 වලින් 0ට යනවා හැබැයි මෙතනින් මොකද වෙන්නේ එකපාරට පල්ස් එකක් එන්න පටන් ගන්නවා ඒ වෙන්නේ මොන වෙලාවේද 0 ගෙන් 1ට යන වෙලාවේ يعني මෙන්න මෙතනින් මෙතනට යන වෙලාවේ මෙන්න මේ රයිසිං එජ් එකේ හරි අපිට එකපාරට පල්ස් එකක් එනවා දැන් අපි ඉන්පුට් එකට දෙන්නේ ක්ලොක් සිග්නල් එක හැබැයි අපේ අවුට්පුට් එකේ තියෙන මොකද එකපාරට මේ එකපාරට පල්ස් එනවා මෙහෙම පල්ස් එනවා ඕම් පල්ස් එනවා right අර අපේ heart beat එක වගේ so that means we have all of a sudden we get a sudden 1 and again get back to 0 okay get back to 0 හැබැයි ඒක වෙන්නේ rising edge එකේ විතරයි falling edge එකේ 1 to 0 වෙද්දි වෙන්නේ නැහැ right 1 to 0 වෙද්දි වෙන්නේ නැහැ so that is where you get that pulse when you go from 0 to 1 මෙන්න මේ 0 to 1 වෙන වෙලාව විතරයි මේ pulse එක තියෙන්නේ 1 to 0 වෙද්දි වෙන්නේ නැහැ so now we can see that all of a sudden we have pulse දැන් අපි බලමු මොකද වෙන්නේ කියලා දැන් ඔන්න සිමියුලේට් කරලා පෙන්නන්නම් වෙන වැඩේ බලන් ඉන්න මෙන්න මේ තැන් වල තමයි පල්ස් එක එන්නේ දැන් එකපාරට මෙයා මාරු වෙලා එනවා ඔන්න 1 වුණා 0 වුණා 1 0 මේ falling edge එකේ මුකුත් වෙන්නේ නැහැ පේනවා rising edge එකේ තමයි 1 වෙලා 0 වෙන්නේ මේ falling edge එකට මුකුත් වෙන්නේ නැහැ ඔන්න ආයි rising edge එකක් තියෙනවා ඔතන එකපාරට 1 වෙයි අන්න so all of a sudden right so when you have this kind of arrangement when you give the input as this you get the output as something like this okay something like this tournament කරලා බලන්න පුළුවන් හැබැයි මේක පල්ස් එක පෙනේ ඉතින් හරි දැන් මේ නොතේරි තේරුම් ගන්න නැතුව නිකන් කටපාඩම් කරලා තේරුමුකුත් නැහැ okay so let's බලමු logically එකේ මම try කරලා නැහැ මේක simulate කරලා සමහරට simulate වෙයි logically බලමු simulate වෙයිද කියලා pulse එක පේන්නේ ඉතින් දන්නේ අපිට So I need AND gate and I need NOT gate. I need a bulb. This goes through the NOT. මම දැන් clock එකක් තමයි high කරන්නේ. මොකද clock එකෙන් සැරින් සැරේ වෙනස් වෙන්නේ. මෙයා ගිහිල්ලා තියෙන not එක හරහා. ඉතා පොඩි හන්ද මේක පේන්නේ නැහැ අපිට හැබැයි. පේනවා. දැන් මෙතන pulse එකක් එනවා පේන්නේ නැත්තේ ඒකයි. හරි. හරිනම් මෙතන pulse එකක් එන්න ඕන. මෙයා rising edge එකට යන වෙලාවේ පොඩි pulse එකක් එනවා. හැබැයි පේන්නේ නැහැ. අපි මේක slow කරන්න පුළුවන් ද ඊට වැඩි. slow කරන්න පුළුවන් කියලා. Because it happens for very small time. ඒක කරන්න දෙන්නේ නැහැ. 10,000 කිව්වේ මම තප්පර 10ක් දැම්මේ. තප්පර 10කට පස්සේ මම අමාරු වෙන්නේ. ඒ පාට pulse එක පේන්නේ නැහැ මෙතන. ඔන්න මාරු වෙන පොඩි pulse එකක් එනවා අපිට පේන්නේ නැහැ මෙයාට. ඒකට අපිට වෙන component එකක් දාන්න තියෙන මේක අර graph එක ඇඳෙන එක. graph එක එකපාරට pulse එකක් යනවා. ඒක නෑ මේකේ. හරි. එතකොට ඔයාලට මෙතන pulse එක එකපාරට පේන්නේ නෑ. If I make it even smaller, sometimes you can see, but we have to wait for very long time. Okay. මෙතන graph එකක් එන tool එකක් තියෙනවා. ඒ graph එකේදී ඔයාලට එකපාරට pulse එක පේනවා. එකපාරට pulse එක පේනවා. But here you don't see it because this is not very sensitive. Okay. So this bulb is just a bulb. Okay. But you can theoretically see. Theoretically, you can identify that there is a possibility of a pulse. Right. There's a possibility of pulse in these points. Okay. ඔන්න දැන් එක වෙලා යයි දැක්කද? මොකද අර මේ ඩිලේ එක ඇතුලේ මේ 1 1 සිටුේෂන් එකකට ගිහලා එකපාරට ආයෙ හැබැයි 0 වෙනවා. Right. So this is how we generate these pulses. Okay, generate these pulses. And remember, now this generate periodic pulses. Yeah, සැරින් සැරේ මෙහෙම pulses generate කරනවා. ඒක දැන් මෙහිම clock එකක් දුන්නම එයාට අපිට output එකට එන්නේ මෙහෙම pulses. මෙයාට දෙන්නේ clock එක. හැබැයි අපිට එනවා සැරින් සැරේ මෙහෙම pulses. Okay, rising edge වල. Okay, right. Now what happens? We have this kind of arrangement. Remember, this is a D latch. අතට අපි මෙයාව ගෙනන විතර connect කරා. not gate එක නැතුව. So this is a gated D latch. හැබැයි දැන් අපි clock signal එක වෙනුවට තියෙන්නේ මොකද්ද? මෙහෙම arrange කරපු clock signal එකක් එයා හැමතිස්සෙම කරන්නේ මෙහෙම සැරින් සැරේ pulse generate කරනවා. Right? Very tiny pulses. Okay. මෙතන ඇඳලා තියෙන normal clock එකක් කියලා edge triggering කියලා තමයි තාම දාලා තියෙන්නේ. ඇතරව okay නේද? Right, now let's see what happens. This is a normal clock. Okay. This is a normal clock. Now this is my clock signal. This is my D, right? Then what are they? Now this is clock is going up. Now D is responding. Now clock is there. Enable. Edge triggering. This is a normal clock, right? Edge triggering clock sorry, edge triggering clock level triggering clock. Right. So at this level, it is triggering. So now D is out high, by Q is high up to this point. Now your D goes down. Have a D goes down, nada. Then may trigger when then trigger when now remember earlier when D goes down, Q goes down. Calling when clock is enabled or when enable is enabled, when your D goes down, your Q goes down. But this one is not a level triggering. This is edge triggering, rising edge triggering. So therefore, it triggers only when clock goes up. මෙන්න මේ තැන් වල විතරයි trigger වෙන්නේ. අනිත් තැන් වල මේ තැන් වල enable නැහැ. හරි. trigger වෙන්නේ enable වෙන්නේ මෙන්න මේ rising edge වල විතරයි. Now this rising edge D is 1, so therefore it is 1. So until this point, it stay there. And in this rising edge, your D is 0, therefore it is 0. Right? So until this rising edge, it is 0. And this rising edge also D is 0, so therefore it remains 0. And this rising edge, your D is 1, so therefore it goes 1. Right? And until this time, it remains there. And this time it is 0, therefore it goes 0. Okay. So therefore, this is a rising edge D latch. Rising edge can make a flip flop because it's an edge triggering. Edge triggering means flip flop. So this is pretty much like a D flip flop. It triggers only for rising edge, not rising, not high level, rising edge. Okay, rising edge with that trigger when. Rising edge is the enable point. All the other places, it is disabled. Okay. So that is a rising edge trigger. Right? Rising edge trigger. Rising edge trigger. Positive edge එක තමයි ගත්තේ අපි. ඒ කියන්නේ මේ සිග්නල් එක පාවිච්චි කරේ. නෙගටිව් edge නම් පාවිච්චි කරන්නේ මේ සිග්නල් එක. හරි. level නම් පාවිච්චි කරන්නේ නිකම්ම ඉර නැත්නම් 0. අපි පාවිච්චි කරේ මෙන්න මේ සිග්නල් එක. ඒ කියන්නේ මොකද්ද? It's a positive edge or rising edge trigger. හරි. rising edge trigger එකක්. rising edge trigger එකේ trigger වෙන්නේ මොන වෙලාවද? It triggers only at these points. So this is a rising edge trigger. All the other places, it just remember. So at this rising edge 1, so therefore 1, until this point anyway 1. At this rising edge it is 0, it is going down. Until this point anyway it is 0. But that rising edge also it is 0, therefore it stays 0. And this rising edge it is 1, so therefore it goes 1 until this point. And in this rising edge it is 0, therefore it goes 0. Okay. So any question on this point? Method na තේරෙනවද? දැන් ටික ටික flip flop වලට ඇවිල්ලා තියෙනවා. ටික ටික ඇවිල්ලා තියෙනවා. So now your Q follows D only at these edges. Only at these edges. Edge එකේ මෙයා 1 නම් 1 වෙනවා. edge එකේ යා 0 නම් 0 වෙනවා. edge එකේ 0 එතකොට 0 එක කන්ටිනියු කරා. edge එකේ 1 යා 1 වුණා. edge එකේ 0 යා 0 වුණා. එතකොට මේ අතර තැන් වල ඒ ඉන්න level එකේම ඉන්න ඕනේ යා. එහෙනම් ඒ අතරතුර යාට මාරු වෙන්න බෑ. මේ අතර තැන් වල මෙයා උඩයට මාරු වෙන්න බෑ. So this is rising edge triggered D latch. Or basically it's a D flip flop. අපිට ඔක falling edge කරන්න ඕන නම් අර වගේම අපිට එකපාර ඒ කියන්නේ අපිට දැන් විදියක් තියෙනවනේ මෙන්න මෙතනදී pulse එකක් ගන්න. මෙන්න මේ එහෙම ගිහිල්ලා. So this is what where we need the pulse. This point අන්න මේකුවා. We need a pulse here. ඒකට කරන්නේ අපි මෙහෙම එක්ක not gate දෙකක් දාලා AND එකකට යනවා. එහෙම නැත්නම් not gate එකක් දාලා O එකට no එකට යනවා. So then when you go from 0 to 1, sorry 1 to 0, 1 to 0 යනකොට එක පාට pulse එකක් එන්න පටන්. මෙන්න මේ තැන් වල pulse එකක් එන්න පටන්. When you go from 1 to 0, there's a pulse. Right. ඒක තේරෙනවද එහෙම එනවා කියලා? So now this is 1, okay? හොඳට බලන්න ඉන්න. So 1 means this is 0. So that is this is 0 and there's a not gate, therefore this is 1. And 0.1 is 0, so therefore this is 0. This is 0. Then on 1. Then අපිට 1 වලින් 0 ට යනකොට අවස්ථාව තමයි falling edge එක කියන්නේ. Now all of a sudden 1 becomes 0. ඒ වෙද්දි මෙතන තියෙන 1 මෙතන තියෙන 0. මේක 0 වෙනවා එකපාරට. හරි. When this becomes 0, this is 1. හරි. හැබැයි චුට්ට වෙලාවකට මේක ඇතුලින් ගියා. හැබැයි තාම මේක ඇතුලින් ගියේ නැහැ. මේක ඇතුලින් ගියාට මොකද මේක ඇතුලින් ගියේ නැහැ. මොකද ඊළඟ ගේට් එකනේ. So at that time this is also 1, this is also 1. 1.1 is 1. So පොඩි වෙලාවකට 1 වෙනවා. මොකද චුට්ට වෙලාවකට මොකද තව චුට්ටක් වෙලා ගියම මොකද වෙන්නේ? මේක 1 හන්ද මෙයා 0 වෙනවා තව චුට්ටක. 0 වෙච්ච ගමන් ආයෙත් මේක 0 වෙනවා. ඒක පොඩි වෙලාවකට මෙයා 0 to 1 වෙනකොට පොඩි pulse එකක් යනවා. චූටි edge එකක් යනවා. චූටි pulse එකක් යනවා. හැබැයි ඒක උනේ කොහෙද? 0 ඉඳලා sorry 1 ඉඳලා 0 වෙද්දි. falling edge එකේ. clock එකේ falling edge එකේ අපිට මෙහෙම pulse හම්බ වෙනවා. Right. So that is why we call it falling edge or the negative edge triggering. Okay. So this also work. එක්ක මේ arrangement එක කරන්න මේක පාඩ arrangement අහන්න exam එකේ හරි නමුත් ඒක. කරන්දරේ තේරුම් ගන්න දු පාඩම් කරන්න බෑනේ හරකෙක් පාඩම් කරනවානේ. Okay. මම මේක ටිකක් දීර්ඝ කතන්දරයක්. ටිකක් අමාරුයි. serious වෙන්න ඕන. එහෙම කියලා කිව්වා නේද මම? Right. So now this is again මේක දැක්ක බය වෙන්න එපා. මේ මොකක්ද තියෙන්නේ? මේ මොකක්ද තියෙන්නේ? මම සමහර එක බඩ බය වෙන මිනිස්සු ගිට දැක්කම සමහරව. මේ තියෙන්නේ මොකක්ද? gated S bar bar latch. gated S bar bar latch එකක් ඔය තියෙන්නේ ආ. මතකනේ S bar bar latch එක හදන්න පුළුවන් NAND gate හතරක් පාවිච්චි කරලා. හැබැයි enable එක විදිහට දාලා තියෙනවද දැන්? pulse generate කරන එක. මෙහෙම pulse generate කරන එක. මතකනේ pulse generate කරන. So that is rising edge. ඒක තමයි මම pulse එක generate කරන්නේ. Now you can see that we have two more lines here. ඒකට අමතරව add කරලා තියෙනවා තව lines දෙකක්. මොනවාද? This one and this one. This one and this one. So what is the use of these inputs? Now we have this clock input, your D, and of course Q and Q bar. Then you have two more inputs. We call it preset input and clear input. Right? Preset input and clear input. Okay. So what is the use of preset input? Preset input. හරිම ලේසි මතක තියාගන්න. Okay. Right. අපි ඉස්සර බලමු මොකද වෙන්නේ කියලා clear input එකේදී. So if clear input is 0, මෙයා 0 කරොත් එහෙම. Remember this is a NAND gate. Forget about the NAND gate. First it's AND gate. So in AND gate, when something is 0, output is 0. Right. මතකනේ AND gate එකක් 0 වෙච්ච ගමන් output එක 0 වෙනවා. අනිත්‍ය මොනවා වුණා. And because this is a NAND gate, when this is 0, AND become 0, but NAND become 1. So therefore, when this is 0, this is 1. So therefore, if you want to make q bar 1 කියන අපි කියන මොකද්ද? reset කරනවා. නැත්නම් අපි කියනවා clear කරනවා කියලා. මොකද මෙයා 1 වෙනකොට මෙයා 0ත් වෙනවා. If you want to make q0 and q bar 1, there's another way. You can just make clear signal 0. Clear signal එක 0 කරන්න. මෙයා 0 කරගමන් කලින් ඒවා අදාළ නැහැ. මේක clear වෙනවා. clear වෙනවා කියන්නේ q0 q bar 1. නැත්නම් ඔක reset වෙනවා. clear කියන්නේ තව වචනයක් තමයි reset කරනවා. set reset set වෙනකොට අපි කියනවා preset කරනවා කියලා. reset කරනවට අපි කියනවා sorry set කරනවා වෙනකොට අපි කියනවා preset කරනවා කියලා. q bar වලට set කරනවට අපි කියනවා clear කරනවා. So basically clear means you make q bar 1 q0. Similarly, if you want to make q1 q bar 0, you make this preset button 0, because when this is 0, regardless of these things, AND gate becomes 0, NAND gate becomes 1. Of course, when this is 1, this is 0. So therefore now we have another mechanism to bypassing this. We have another mechanism to either preset to 1 or clear to 0. Clear කරන්නත් පුළුවන්, preset කරන්නත් පුළුවන්. මොකෙන්ද? මේ input එකනේ මේ input එක. This is clear. That means this is 0, this is 1. When this is 1, 0. When preset is 0, your q is 1, q bar is 0. යොකත් අහන්න පුළුවන් exam එකේ. හරි. මොකද යාගේ circuit diagram වල තව input දෙකක් දකින්න සමහර තැන් වල. මේක එච්චරම වැදගත් නෑ. preset clear ගැන බොහෝ විට අහන එකක් නෑ exam එකේ. හැබැයි ඇහුවොත් කියලා තමයි කිව්වේ. මොකද note එකෙන් කියනකොට ඔය preset clear ගැන තියෙනවා. But don't make both 0. මොකද දෙකම 0 කරොත් එමාට 1 1 scenario එකට යනවා. හරි 1 1 scenario එකට යනවා. 1 1 scenario එකකින් වැඩිත් නේ. So therefore don't make both preset and clear 0. Okay. But if both preset and clear are 1, that is normal working flip-flop. ඒතර හැමතිස්සෙම කරන්න ඕනේ මේ දෙකම 1 කරලා තියන්න ඕන. එතකොට සාමාන්‍ය විදිහට වැඩ කරනවා. But at any time, if you want to preset, make sure this is 0 and this is 1. And if you want to make it clear, make sure this is 0 and this is 1. But in normal situation, both are 1. Both are 1. Okay. Both are 1 කියන එක තමයි සාමාන්‍ය situation. Right. Now we can get into the final part. Right. अब synchronize එක ගැන කතා කරා. Right. Anything method නම් clearද? So anything else you want me to explain? Because now we are halfway into the topic. Okay, චුට්ටක් කරාට පස්සේ ඉවරයි. ඉතින් past paper question වලට යන්න පුළුවන් අපිට ඊට පස්සේ. මේ past papers වලට යන්න නම් මේ දිගේ එන්න ඕන. හරි. 2020 question 39. 2021 question 35. Any questions up to this point? Presets are clear ගැන තේරුණාද? This is just a gated D-latch. හරි. gate එක වෙනුවට අපි enable වෙනුවට පාවිච්චි කරලා තියෙන්නේ. pulse generate කරන clock. මෙතන clock එක මෙතන කරන්නේ pulse generate කරන. නිකම් clock එක එකපාර දුන්නේ නැහැ. මොකද නිකම් clock එක දුන්නොත් එහෙනම් ඕක level triggered. edge triggered කරගන්න තමයි මේක දුන්නේ. ඒ නැත්නම් symbol එකේ දෙනවා edge triggered කියලා දෙනවා. හරි. ඒ clock එකේ අර එන pulse වල විතරයි දැන් මෙයා enable. හොඳට මතක තියාගන්න. මෙහෙම සැරින් සැරේ එනවා pulse. All the other times your circuit is disabled. මෙන්න මේ තැන් වලදී විතරයි circuit එක enable. Okay. That is why we prefer edge triggering rather than level triggering. Right. So this is another important concept. The D flip-flop as a delayed flip-flop. Okay. හොඳට බලන් ඉන්නවා මේ කියන එක මේකත් exam එකේ අහන්න පුළුවන්. හරි? Right. So now remember this is my clock. And let's assume it's positive edge triggering clock. Positive edge triggering වලට තමයි මේක set කරලා තියෙන්නේ. This is where your circuit is enabled. ඔන්න ඔය point වල විතරයි circuit එක enable. In other times your circuit is sleepy. එයා හිතේ තියෙන එක හිතේ තියාගෙන ඉන්නවා. එයා ගණන් ගන්න අනිත් ඒවාට respond කරන්නේ නැහැ. So only in this point of time your circuit is enabled. Okay? Circuit is enabled. Right, now what happens? Remember Q follows D. D වෙන්නේ මොකද්ද? Q ත් ඒක වෙනවා. Circuit එක enable නම්. හැබැයි circuit එක disable නම් එයා respond කරන්නේ නැහැ. Now you can see ඔන්න එයා respond කරනවා. ඉස්සෙල්ලාම Q0. So this is the first time you have a rising edge. So at that time D is 1. So therefore your Q is also 1. මොකද ඒ edge එකේදී යා D follow කරනවා. හැබැයි edge එකේදී. Now until this point nothing will change. මෙන්න මෙතන නිකන් එයා වෙනස් වෙන්නේ නැහැ. ගත්ත value එකෙම ඉන්න ඕනේ. මොකද ආයි respond කරන්නේ මෙතනදී. And at that time again you can see D is 1. එහෙනම් එයා ආයි ඊළඟ edge එක වෙනකන් ඒත් වෙනස් වෙන්නේ නැහැ. Right. And in that edge D is 0. So therefore it goes down. And it doesn't change until the next edge. ඊළඟ edge එක මෙතන පෙන්නලා නැහැ නේ. එහෙනම් දිගටම එයා එහෙම ඉන්නවා. Okay. So this is different. This is now edge triggered. Now triggering happens only in this edge, this edge, this edge. But at the edge, your Q follows D. D1 and the 1 වුණා. මේ වෙලාවේදී D1 ම තමයි තියෙන්නේ. හැබැයි මේ වෙලාවේ වුණ D0 යා 0 වුණා. ආයි ඊළඟ edge එක වෙනවා නේ වෙනස් වෙන්නේ. So sometimes we call it delay flip flop. Okay. It's a delay D flip flop. මොකද එයා එකපාර respond කරන්නේ නැහැ D ට. නේද? එකපාර respond කරන්නේ නැහැ. මේ වගේ pricing edge එකක් එනකන් එයා respond කරන්නේ නැතුව පරණ එකේම ඉන්නවා. හරි. තේරෙනවද? ඊළඟ rising edge එකේදී විතරයි එයා respond කරන්නේ. දැන් මෙයා 0 වෙලා හිටියේ. හැබැයි එයා 0 වුණාට මෙයා immediate 0 වෙන්නේ නැහැ. මේ rising edge එකේ තමයි එයා detect කරේ මෙයා 0 වෙලා කියලා 0 වුණා. Okay. So that is why we say delay flip flop. පොඩි delay එකක් තියෙනවා. හරි. හැබැයි delay එක ඇතුලේ මෙයා මොනාරි උඩපට උනාට ගණන් ගන්නෑ. හරි. stray signal ආවට වැඩක් නැහැ. stray signal මේ gap එකේදී ආවා කියලා මේ D වෙනස් වුණා කියලා එයා ගණන් ගන්නෑ. හරි. මේ gap එකේ වෙනස්කම් වලට එයා respond කරන්නේ නැහැ. So that means our flip flop is now it's a flip flop. It respond only in this type of a time slots. මෙන්න මේ time වල තමයි enable respond කරන්නේ. අනිත් හැම වෙලාවෙම මෙයා disable. Right. So when it comes to understanding flip flops, we can use 3 type of things, artifacts. We call it truth table, characteristics table, and excitation table. So don't worry too much about those things in your BIT semester 1, of course. Right. So don't worry about these things right now. Okay. Right. අපි බලමු දැන් ඔයාලට 2021 paper එක කරන්න පුළුවන් කියලා. ඒක ඇත්තට මේක delay flip flop එකක් තමයි දීලා තියෙන්නේ. D flip flop එකක්. Okay, so this is 2021 question 35. So those who have the 2021 paper, you can see this question. So there's a clock here. Right, there's a clock here. Same clock is connected here. A clock එක මෙතනත් connect කරලා තියෙනවා. Same clock. right? So then you have two latches. මොනවද කියලා කියලාත් නැහැ. So then you have no gate, right? No gate. So this is your clock and this is your output. Output එක ආයි feed කරනවා මෙතනට. එහෙන් feed කරනවා මේකටම output එකක් යයි. So the question is, now which of the following these are the sequence of the output state of Q0 and Q1? So these are the output Q0 and Q1. And this output is input to this one. For the circuit shown below, assume that the starting state at the first clock pulse is 0, 0. Right? First clock pulse එක මේක 0, 0 කියලා හිතන්න. ඒකේ බලන්න. ඒකේ මේ Q0, 0 කියලා හිතන්නලු. Q1, 0 කියලා හිතන්න. So assume that this is 0, this is 0. Question එක දීලා තියෙනවා හරි. Assume that the starting state at the first clock pulse is 0, 0. කියලා කියනවා ඊට පස්සේ Q0 is 0, Q1 is 0 කියලා හිතන්න. පටන් ගන්න වෙලාව. Okay. Right. So the question is, which of the following these are the sequence of the output state? මේ මොනවද අහනවා මේවෙන් හරි උත්තර. Output state එකට එන්න. Output state කියන්නේ Q0 and Q1 හරි. Q0 and Q1. පටන් ගන්නකොට Q0 0 ලු Q1 0 ලු. Starting point. Right. And clock signal is also there. So is this one, this one, this one, this one, this one. කොහොමද මේක කරන්නේ? ටිකක් අමාරු question එකක්. හරි. So this is how you do it. Now remember, this D0 is Q0 plus Q1 bar. Because this is Q0 and this is Q1. Q0, Q1. And this is a NOR gate. So therefore my D0 will be this. So therefore my D0 is Q0 plus Q1 bar. මේ දෙක ඕවලා not කරන්න. මොකද මෙහෙට input එක යන්න ඕනේ. And also D1 is same as D0. මොකද D0 කෙනෙම connect කරලා තියෙන්නේ. That is our starting point. Right? D1 is same as D0. And D0 is Q0 plus Q1 bar. Okay. I hope you can understand that. දැන් අපෙන් අහන්නේ පටන් ගනිද්දි මේ දෙක මොකද්ද? Q0 Q1 0 0. ඒ කියන්නේ පටන් ගනිද්දි කොහොම 0 0 කියලා තියෙන්නේ? That is given. At the starting point Q0 is 0, Q1 is 0. So now let's create a table. Q0 Q1. Q0 Q1. ඊළඟ අපිට ආයෙ ඕන නමද? D0 D1. මොකද ඒක තමයි input වෙන ඊළඟ පාරේ. මේ හරි. So the real input. Now we start with output of this one and this one. But next time we need D0 and D1. column there. So then we'll have, when you have D0 and D1, we need the next clock pulse Q0 and Q1. So this is current Q0 and Q1 na 0 0. කියලා තියෙනවනේ. So then using the current Q0 and Q1, we can calculate the D0 and D1. Once you know the D0 and D1, we can calculate the next Q0 and Q1. මොකද මේක දිගින් දිගටම වෙනවා දැන්. දිගින් දිගටම වෙනවා. Right. Right. So you can see one thing, that is your Q0 is same as D1. මේ Q0 ම තමයි D1 වෙන්නේ. ඒක තේරුණාද? Q0 තමයි feed වෙන්නේ D1 කියලා. Okay. And that D1 will be your next Q1. ඔය D1 ම තමයි ඊළඟ Q1 වෙන්නේ. ඊළඟ clock pulse එකේ. එක clock pulse එකක් යනවා මෙයාට මේක process වෙන්න. එතකොට ඊළඟ clock pulse එකේ Q1 is previous clock pulse D1. So therefore next clock pulse Q1 we'll call it Q star. Q1 star. එහෙම නැත්නම් Q1 ඉවත් කවන්නේ. Okay. So Q1 star is D1. Then what about the next clock pulse D0? That is previous clock pulse Q0 plus Q1 bar. Q0 plus Q1 bar. එතකොට අපිට Q0 Q1 දන්නවනේ අපිට ඊළඟ D0 හොයන්න පුළුවන්. හරි. D0 හොයන්න පුළුවන් මොකෙන්ද? Q0 Q1 දන්නවා. Okay. So therefore now we can start with Q00 Q10. Q00 Q10. Okay. So that means this is 0, this is 0. That means this is 0, this is 0. Now I can find D0, that is 0 plus 0 bar, which is 1. Then I want to මේකයි දාලා අපි මේක හොයාගන්න. So that means now this is 1. Sorry, no, this is 1. D0 is 1. Okay. And that D0 will be the Q0 next time. ඊළඟ clock pulse එකේ Q0 වෙන්නේ මේ D0 ම තමයි. මොකද මේක D flip flop එක. දැන් මෙයා 1 කියන්නේ මෙයා 1. Okay. And that is D0 is your your D0 is your Q0. මෙයා 1 කියන්නේ මෙයා 1. Okay. But at the same time your D1 is same as Q0. D1 වෙන්නේ Q0. එහෙනම් මේ Q1 Q0 ම තමයි D1 වෙන්නේ. So therefore when this is 0, this is 0. And that value is this value in the next clock pulse. මොකද delay එකක් තියෙනවා. So therefore whatever the D1 is your Q10. So then ඔන්න අපිට පළවෙනි රවුම හරි. Now again I can calculate Q0. Then ඔන්න පළවෙනි රවුම හරි. Now I can calculate the Q0 which is previous D0. Q0 is the D0. Okay. So therefore this is 1 means this is 1. Okay. So that is how you start. Then you know the Q1 which is 0. Okay. This 0. So then I can calculate new D0. 1 0 මේක දාලා calculate කරන්න ඕන. So you will get 0. And that will be Q0 star. මේ D0 තමයි මේ D0 තමයි Q0 star වෙන්නේ. ඒ කියන්නේ ඊළඟ Q0 වෙන්නේ මේ D0 ම තමයි. But this is a D flip flop. This is a D flip flop. And D1 will be same as Q0. D1 will be same as Q0. So therefore when this is 1, this is 1. Right? So likewise you can go from this line to this line, this line to this line, this line to this line. And now you can see the output. Right? Output එක වෙන්නේ මොකද්ද? 0 0. Remember what they need is Q0 and Q1. Right? Q0 and Q1. 0 0, then 1 0, then 0 1, then 0 0. 0 0 1 0 0 1 0 0. 0 0 1 0 0 1 0 0. Again it will be 1 0. So answer is C. Okay. Answer is C. So this is not easy question. Right? Very fairly difficult question, but you have to remember these are just delay latches. Delay latches. මෙයාගේ වැල්යු එකම තමයි තව චුට්ටකින් මෙයාගේ වැල්යු එක වෙන්නේ. D0 ම තමයි Q0 star වෙන්නේ. හොඳට මතක තියාගන්න. මේ D0 ම තමයි Q0 star වෙන්නේ. මේක 1 නම් මේක 1, මේක 0 නම් මේක 0, මේක 0 නම් මේක 0, මේක 1 නම් මේක 1. ඒක තමයි පළවෙනි කොටස. හරි. D0 ම තමයි Q0 වෙන්නේ. මොකද මේකෙදි වෙන්නේ එක clock pulse එකක් delay වෙනවා. මෙතන input එක වෙනවා. මෙතන D1 ම තමයි Q1 වෙන්නේ. D1 ම තමයි හොඳට බලන්න මම කියන එක. D0 ම තමයි Q0 වෙන්නේ. හරි. හොඳට බලන්න ඒක වෙනසක් නැහැ නේද කියලා. This is D0 which is same as Q0 star කියලා දැම්ම ඊළඟ clock pulse එක වෙනවා. 1 1 0 0 0 0 1 1. And this is another D flip flop. Your Q1 star will be D1. Q1 star කියන්නේ ඊළඟ clock pulse එකේ Q1 කියන්නේ. Q1 star will be same as D1. ඒ කිව්වේ මෙන්න මෙයා ම තමයි මෙයා වෙන්න ඕනේ. පේනවා 0 0 1 1 0 0 0 0. ඊළඟට දැනගන්න ඕන this Q0 is D1. මේ D1 වෙන්න ඕන Q0 ම තමයි. ඒකන් තමයි මේක 0 0 1 1 0 0 0 0 උනේ. හැබැයි එක මේක වෙනම හොයන්න ඕන. D0 වෙන්නේ මේ Q0 Q1 දාලා මෙතනින් හොයන්න ඕනේ ඒක. D0 හොයද්දි විතරක් පාට මෙන්න මෙයා හොයද්දි මේ ෆෝමියුලා එක දාන්න වෙනවා. එතකොට මේ ලයින් එකකින් ඊට පස්සේ මේ එකෙන් මේකට ට්‍රාන්ස්ෆර් වෙන්න ඕනේ, මේකෙන් මේකට ට්‍රාන්ස්ෆර් වෙන්න ඕනේ, මේකෙන් මේකට ට්‍රාන්ස්ෆර්. So the idea is this is a delay latch. කලින් D0 තමයි ඊළඟ පාර Q0. කලින් D1 තමයි ඊළඟ පාර Q1. හරි. ඊළඟට වාට පේන්න ඕන Q0 ම තමයි D1. එතන ඩිලේ එකක් නැහැ. මෙතනින් එන එක කෙලින් මෙතන යනවා. මොකද මෙතන කොම්පොනන්ට් එකක් නැහැ. ඩිලේ එකක් නැහැ එතන. ඔන්න ඔළුවට ගත්තොත් එහෙම කරන්න පුළුවන්. හොඳට කල්පනා කරලා බලන්න. හරි. It's a difficult question, but that is the question. That is one of the question they have given. 2021. Right. So then we have another concept called master slave D flip flop. Okay. So this is another important arrangement where look at what they have done. So this is my clock signal. This is the clock signal. And this is inverted clock signal. A clock signal එක මෙයාට දීලා තියෙනවා. එකම latch එක. හරි පේනවද? DQ CQ bar. හැබැයි මෙයාගේ clock signal එක invert කරලා මෙයාට දීලා තියෙනවා. ඒ කියන්නේ මෙයා 1 වෙනකොට මෙයා 0. මෙයා 0 වෙනකොට මෙයා 1. මෙයා rising edge වෙනකොට මෙයා falling edge. Okay. So if you arrange like this, right? If you arrange like this, we call it master slave D flip flop. Okay, master slave D flip flop. So what is the advantage of master slave D flip flop? Right, read this. The circuit accepts the value in the input when the clock is high. So when the clock is high, this accept the input and pass the data to the output on the falling edge of the clock signal. මෙහාට දෙන්නේ falling edge එකේ. This make the master slave JKO, we call it D flip flop, synchronous device as it only passes data within the timing of the clock signal. මෙයා මෙතනින් මෙතනට යන timing එකේදී විතරයි. Right? Timing එකේදී විතරයි. That means it is locked. So when input is active, output is locked. When output is active, input is locked. So that is why we call it locked latch or master slave latch. Okay. Right. So now you can do this particular example. Okay. This particular example. Right. So this is my D. හොඳට බලන් ඉන්න. මේ වගේ question එකක් දෙන්න පුළුවන්. This is my D signal. This signal, okay? It's just a signal. And you have the clock. You have the clock. Now what happens is, assume it is level triggered. Now I'm interested in QM, not QS, okay? Level triggered කියලා හිතන්න. Now here it is level, clock is enabled, but D is 0. So therefore still it is 0. Anyway, now this is disabled. Level triggered කියලා හිතන්න. Now you can see that now clock is enabled. Now D is positive. Therefore now your Q follows D. Q follows D. Now it is disabled. Disabled වුණාම මොකෝ යා memory එකක ඉන්නවා. Memory එකක ඉන්නවා. Now again it become enable. හොඳට බලන්න ඉන්න enable වෙනවා. Enable වුණාම මොකද වෙන්නේ මෙයා Q0. Q0 හඳ මොකද කරන්නේ? මෙයාත් 0 වෙනවා. මොකද මේක level trigger. This is not edge triggering. Assume level triggering. So when clock is enabled, now it responds. Okay. Now again, D become high, so therefore Q become high. Now it's disabled, so therefore it stays there. Now enable one high thing, so therefore still high. Now of course it is disabled. Disable la respond karanne. But now enable not me low, low. Now it's enabled, but it is still low. Now it's enabled. Until this point, it is now disabled. Now again enable, by enable time, it is positive. So therefore it's positive. But now it goes down. This becomes 0. Therefore now Q becomes 0 and goes like that. Now this is edge triggering. What I mean edge triggering වල තියෙන ප්‍රශ්නයක් වෙන්න නේද? Because it's edge triggering, now your Q responded to some pulses. Let's assume this is a stray pulse. මේක වැරදීමක් විදිහට ආපු එකක්. හැබැයි වැරදීමකින් ආවට මොකද මෙයා respond කරනවා. මෙයාට වැරදීමෙන් ආවද කියලා ප්‍රශ්නයක් නැහැ. ඔයාගේ Q follow කරනවා. මොකද ඒක edge triggering. Sorry, level triggering. Level triggering. Clock එකේ level එකට trigger වෙලා තියෙන. ඒක හන්ද මෙන්න මේවට respond කරා. Right? Respond කරා. This QM, right? This QM responded. Now let's look at what happened to QS. Right? QS the clock එක invert කළා දියා තියෙන. So to the QS we have given the negation of the clock. Okay, so now remember, now we have already taken the QM. Now QS is enabled when the clock is low level. Low level එකේ විතර යා enable respond කරන්නේ. එයාගේ input එක මොකද්ද? QM. Its input is QM. But it is enabled when clock is low level. ඒ කියන්නේ clock එක මේයි විතර යා respond කරන්නේ. කලින් respond කරේ positive time. Remember, QS is same as QM. QS is same as QM. But it follows, QS follows QM when clock is low. Now clock is low, yeah, follow kar. Yeah, follow kar. QM. Now still QM is low. Yeah, follow karna. Clock then. On them follow karna. Have I low? Low. Then yeah, memory එක ඉන්නේ. හොඳට මතක තියාගන්න. Now clock is high. Clock high වෙනකොට මෙයාගේ clock එක low. හරි මෙයා clock එක low. එයා දැන් මොකද කරන්නේ? එයා memory. එයා memory එකේ ඉන්නේ. So now again clock is low. Right? So your QS follows QM. On the QM high, the QS උත් high වෙනවා. මොකද clock එක දැන් low level එකේ අපිට මෙයා enable. Low කියන්නේ enable. මොකද not කරන්නේ? So now again enable. So therefore it is 1. Now it is disabled. High කියන්නේ disable. මොකද not කළා තියෙන්නේ. ඒකන්ද ඒ වෙලාවේ මෙයා මේ QM follow කරන්නේ නැහැ. It doesn't follow QM because now it is disabled. So therefore මේ glitch එක එයා ගණන් ගන්න නැහැ. එයා දිගට memory එකේ ඉන්නේ. And now again enable, but it is anyway 1. This is disable. Right? Now again clock is 1, that means disable. Right? Disable කියන්නේ යා memory එකේ ඉන්නවා. Now clock, now enable. इधर मैं follow करना. Now you can see again high can disable. Disable ना मैं follow करना है. Because this is disable. Remember not take दिया ना. Enable क्या नहीं कर. वरना मैं disable आवाज आया था मैं pulse का आवे pulse का क्या respond करना था नहीं. It doesn't respond to this pulse. Therefore it goes like that. Now you can see earlier we had two glitches. मैं वो error दिया था. मैं glitch से आती हूँ. හැබැයි දැන් මොකද කරන්නේ? මෙයාට glitch දෙක ආවට මෙයා ඒ glitch දෙක ignore කරනවා. තේරෙනවද? මේ දෙක යාට තේරෙන්නේ නැහැ. මොකද ඒ වෙලාවේ මෙයා disable. high කියන්නේ disable. හරි. ඇත්තට මේ pulse දෙක වැරදිලා ඇවිල්ලා තියෙන්නේ. හරි වැරදිලා ආවේ. ඒ pulse දෙකේ වැරදීමට මෙයා respond කරාට මොකෝ මෙයා respond කරන්නේ නැහැ. මෙයාට තාම පේන්නේ මේ පල්ස් එකට පේන්නේ හරියට මෙයා මෙහෙම ආවා කියලා. ඔන්න ඔහම ගියාවා. හරි. හැබැයි ඒක උනේ මොකද? මෙන්න මෙයාට ඉන්වර්ටඩ් ක්ලොක් එක දුන්නා හන්දා මෙයාට ඒ වැරද්ද පෙවුනට මොකෝ ආයි මෙයා ඒ වැරද්ද හදනවා. So the slave fix that issue. So this you can see there are some glitches, but those glitches are again cleared out. I clear out it in the slave. So it's an interesting phenomena, right? It's an interesting phenomena. So let's assume these are some stray signals. මේක වැරදිලා ඇත්තට මෙයාට හරි සිග්නල් එක යන්න තියෙන්නේ මෙහෙම. හරි සිග්නල් එක යන්න තියෙන්නේ මෙහෙම. මේ වැරදිලා පොඩි ස්ට්‍රේස් දෙකක් ගියා. ඒ ස්ට්‍රේස් දෙකට මෙයා රෙස්පොන්ඩ් කරා. QM. හැබැයි ආයි QS ට යනකොට ඒවට රෙස්පොන්ඩ් ඒවා ආයි කැන්සල් වුණා. වෙනවද? ඒ ස්ට්‍රේ සිග්නල් දෙක කැන්සල් වුණා. So therefore now my QS is proper output. It has not responded to these stray signals. Okay, stray signals වලට respond කරේ නැහැ. stray signals වලට මෙයා respond කරාට මොකෝ ආයි ආව clear කරා මෙයා. Right. So that is how the master slave D flip flop work. Okay. But again, this is not a really a flip flop because this is responding to the trigger. This triggers to the levels. මොකද මෙයා level වල trigger කරපුවාම තමයි ගුණය. හැබැයි level වල trigger කරත් ආයිමත් ඒක වැරද්ද හැදලා දුන්නා. Now this is not edge triggering. Though it is not edge triggering, still those glitches are cancelled out. It's a clever way of using level triggering and still you eliminate the glitches. Right? So you are using two edge triggering latches. But while you are using two edge triggering latches, one is positive edge triggering, other is negative edge triggering. But still those glitches are cancelled out. The way we have arranged it. So that is called master slave D flip flop කියලා කිව්වට කමක් නැහැ. දැන් මොකද flip flop latch උනාට එයා flip flop වගේ තමයි හැසිරෙන්නේ. අපි level triggering වලට ගියාට එයා හරියට නිකන් edge triggering වගේ හැසිරෙනවා. Okay. Right. Now we can look at the JK latch. Last one. මෙතන තමයි අපිට එන්න ඕනේ. මෙතන තමයි that is the end point. So JK latch can be created using two NOR gates. ඒ කියන්නේ SR latch එකම අරගෙන this is not a JK flip flop, this is JK latch. So you create two NOR gates, so that is something like your SR latch, but then you have two NAND gates. So sorry, two AND gates. But remember, there's no clock signal or enable. This output is input to this, and this output is input to this. And rather than SR කියනකොට දැන් අපි කියන මේකට මොකද්ද JK කියලා කියන්නේ. So JK stand for Jack Kilby, the two people who came up with this latch. ඒ දෙන්නගේ නම් දෙක. So remember the J is same as S, K is same as R. හැබැයි මෙතන වෙන gate දෙකක් තියෙනවා. Okay, so this is basically your R, this is S. If you just consider this as SR latch, but now you have two AND gates. ඒ AND gate දෙක දැම්ම නැත්නම් Jack සහ Kilby. ඒගොල්ලෝ කිව්වා අපි මේකට JK flip flop කියලා ඒගොල්ලෝ නමක් දැම්මා with those two AND gates. Now we are back to the latches. Okay. And the good news is this JK latch behaves exactly as the SR latch. يعني S වෙනුවට J වෙනුවට S කියලා K වෙනුවට R කියලා වැරද්දක් නැහැ. But there's advantage. Now remember R1 S0 is reset. S1 R0 is set. 0 is memory. And remember SR latch had an issue. If we have both S equal 1, R equal 1, it goes to oscillation or race condition. දෙකම 1 වෙන්න පටන් ගන්නවා ඊට පස්සේ දෙකම 1 වෙනවා දෙකම 0 වෙන්න පටන් ගන්නවා පුටපට වෙනවා. Right. So that problem is still there. Right. So when both S and R are 0, or now we can call it both J and K are 0. Sorry, both J and K are 1. it goes to oscillation. That means QT plus 1 is bar of QT. Make a 1 වෙනකොට මෙයා 0 ඊළඟ වෙලාවේ මෙයා 0 මෙයා 1 ඊට පස්සේ ආයෙ මෙයා 0 මෙයා 1. ඒකට අපි කියන මේක oscillate වෙනකොට time. So that is the issue with the normal SR latch, and still that issue is with the JK latch. මේ AND gate දෙක දැම්මම. හරි. So now you should be able to understand how to set and remember and reset and remember. Okay, so this is set and remember, and this is reset. මතකනේ J කියන්නේ S, K කියන්නේ R. So reset and remember. But you must not let J equal 1, K equal 1. J equal 1, K equal 1 කියන්නේ අන්තිමට මොකද්ද? S equal 1 කතන්දරේම තමයි. So you must not let both 1 because it goes to racing or oscillated. 0 1 මාරුයි යනවා. 0 1 මාරුයි යනවා. Okay. So that is JK latch using NOR gates. Now let's see what happens if you create JK latch using NAND gates. Same thing, කලින් වගේම තමයි. එකම වෙනස මෙයාගේ input එක මෙයාට දෙනවා. මෙයාගේ output එක මෙයාට දෙනවා. So this output is given input to this one, and this output is given as input to this one. And now we can call it JK latch. JK latch. That is JK latch using NAND gates. Earlier JK latch using NOR gates. Again, you can do the set and remember, reset and remember. Still you can do that. Set and remember, reset and remember. Okay. Still we have issue. Still we are talking about the JK latch. Still we have the racing condition where S and the two outputs keep on oscillating. So the solution is modify your JK latch to introduce clock signal. Right? Clock signal. So what we can do is we can make it introduce a clock signal as the third input to this two AND gates. Okay. But if you go for level triggering, still the problem is there. Level triggering වලට ගියොත් තාමත් problem එක තියෙනවා. Right? Now you have the clock signal, but assume level triggering. Right? So then we have the J, K, and Q. Remember, J is same as S, K is same as R. Now remember, we go for high level triggering. So this is where the triggering. මේ වෙලාවේ තමයි ආගේ enable. දැන් driving diagram හදින්න පුළුවන්. Right. Now what happens? J is 0, K is 0. Assume that we start with 0, J0, K0 කියන්නේ මොකද? memory. අය අධිකරණ memory එකේ ඉන්නවා. අපි පටන් ගමු නිකන් බිඳුවෙන් කියලා. Sorry, 1 වලින් පටන් ගත්තා කියලා. And of course this is disabled. Now R become 1, S is 0. But remember, when clock is 0, it is disabled. So therefore it stays there. මේ වගේ එහෙම ඉන්නවා. Now of course, now R is 1, S is 0, now enable. Enable එක මොකද? R කියන්නේ reset. Reset කියන්නේ S, K කියන්නේ R. So therefore now it is 0. Now both J and K, K is 1, S is R is K is 1, J is 0. ඔයාලට K හිතාගෙන R කියලා. හරි, JK කියන්නේ SR. මොකද SR අපිට මතකයිනේ. So now එක තමයි JK වැඩි පාවිච්චි කරනවා, මම පාවිච්චි කරන SR කියලා. හැබැයි මේක JK flip flop එක. හරි, මොකද මේ get දෙයක් තියෙනවනේ. Now of course during the clock signal is enabled. Now R is 1, S is 0. That means it is 0. Now of course clock is 0. That means it's remember. Then you have respond කරන්නේ. Now again enable. Both J and K are 0. You can memory. Now disable anyway memory. Now by the time clock goes up, you can see SC is 1, R is 0. They can set වෙලා තියෙනවා. ඔන්න set වුණා. Now S remain 1 and J R remain 0. and මෙතන වෙනකම් ඕක වෙනසක් වෙන්න ඉඩ නැහැ. Anyway, අතරතුර clock එක disable වෙනවා. Now again clock is enabled. Now memory both S and R are 0. But at this point you can see that now enable both S is 1, R is 1. ඔන්න racing situation එකට ගියා. මේ හරිය racing. හරි I disable වෙනවා. when I clock එක racing situation එකට යනවා because now clock is enabled both S is 1, R is 1. Remember S is 1, R is 1 means invalid racing situation. So therefore, though you introduce the clock signal, as long as you go for edge triggering, still you have the racing situation. Still you have the racing situation. So therefore, introducing clock as an enable disable doesn't work if you go for edge triggering. Sorry, if you go for level triggering. Right? If you go for level triggering, still the problem is there. Still racing situation. මේක දිගටම වෙනස වෙනකම් oscillated pattern. So therefore, this is not a solution. Right? Just adding a clock key is not a solution. If you go for level triggering. Okay. So therefore, what we need is edge triggering. මේ තියෙන edge triggering කරන්නේ මේකනේ මතකද චුට්ට වෙලාවකට 1 වෙලා යන්නේ. චුට්ට වෙලාවකට this is positive edge triggering. Now what happens if you use JK flip-flop with positive edge triggering? So this is positive edge triggering, okay? Positive edge triggering. And when positive edge එකේ තමයි trigger වෙන්නේ. Positive edge එකේ තමයි trigger වෙන්නේ. දැන් clock එකේ ඇඳලා තියෙන positive edge විතරයි යා. This is positive edge. And mean positive edge එක. Because other times the clock is circuit is disabled. Now what happens? Now at this point, your J is 0, K is 1. ඒ කියන්නේ J කියන්නේ S, R කියන්නේ reset. JK, K කියන්නේ reset. Now that means it is reset. On a reset වෙනවා. දැන් මේ වෙලාවෙදි වෙනකම් ඔක වෙනස් වෙන්නේ නැහැ. But at that time, both are 0. That means memory. මෙතෙන් තමයි වෙනස් වෙන්නේ. එතක වෙනස් වෙන්නේ නැහැ. But at that time, you can see set is 1, or J is 1, K is 0, R is 0. You can J can set, only then set to now. මෙතන වෙනස් වෙන්නේ දෙයක් නැහැ. But at that time also, J is 1, R is 0. මෙතන වෙනස් වෙන්නේ දෙයක් නැහැ. But at that time, what happens? Your R is 1, S is 1. Fair. මෙතන තව මොකද වෙන්නේ? Your K is 1, your S is 1. Then number 1 1. Then number 1. But in JK flip flop, when both are 1, it is toggle. හොඳට මතක තියාගන්න ඕනේ. SR flip flop එකේ JK flip flop එකේ වෙනස තමයි ඒක. So if you look at the SR flip flop, now look at this one. If you look at the SR flip-flop and JK flip-flop, in JK flip-flop, S equal 1, R equal 1 is toggle situation, not a racing situation. Right? Right. Other than that, it is same as JK. So this is JK flip-flop. K is 1 means reset, that is R is 1. J is 0, K is 0, J is 1, K is 0 is set. 0 0 is memory. But remember in SR flip-flop or latch, 1 1 is racing situation. But in JK flip-flop, 1 1 is toggle. Toggle වෙනවා කියන්නේ කලින් 1 හිටියා නම් මෙයා 0 වෙනවා. කලින් 0 හිටියා නම් 1 වෙනවා. මුතර මතක තියාගන්න ඔන්න ඕක. හරි? So therefore now what happens here? Now we have in a rising edge, we have a situation where both J and K 1. JK දෙකම 1 වෙච්ච situation එකක්. ඒ වෙලාවෙ මොකද වෙන්නේ මෙයා? toggle වෙනවා. මෙයා කලින් 1 නම් ඉතින් 0 වෙනවා. ඒක තමයි මෙතනට නිකන් වෙන්නේ. ඔන්න 1 1 situation එකක් තියෙනවා toggle වෙනවා. ඔන්න ආයි pulse එකක් තියෙනවා. මේ වෙලාවේ ආයි 1 1 ඔන්න toggle වෙනවා. හරි. ඔන්න ඕක තමයි මතක තියාගන්න. Okay. So in JK flip flop, J equal 1, K equal 1 situation, that is that pulse is where your output is toggle. Output එක toggle වෙනවා. Okay. So therefore 0 0 means no change. 1 0 means set because J is same as S, K is same as R. 0 1 means reset. 1 1 means toggle. It is not a racing situation, it is toggle. Whatever the current value is, toggle. If current value is 0, new value is 1. If current value is 1, new value is 0. Okay. But that happens only in the rising edge. In all the other situations, nothing change. Clock pulse එක මෙහෙම rising edge එක විතරයි මේවත් වෙන්නේ. අනිත් හැම වෙලාවකම ඒ කියන්නේ මේ වගේ ඕන වෙලාවක එයා ගණන් ගන්න නැහැ, respond කරන්නේ නැහැ. මෙතෙන්දි විතරයි respond කරන්නේ. එතෙන්දි respond කරන truth table එක තමයි මේ කිව්වේ. The good news is 1 1 is not a invalid scenario. 1 1 is toggle. 1 1 is toggle. Okay. Now we can do the other past paper question. Okay. Right. It says JK flip flop. ඔන්නට question එක කියලා දෙනවා මේක JK flip flop එකක් කියලා. හොඳට බලා ගන්න. JK flip flop එකක්. This is Q and Q bar. Clock is there. Right. And this is my output Q. දැන් ඔයගොල්ලෝ දෙන්න නිකම්ම JK flip flop එකක් දෙන්නේ නැහැ. මේකට දෙන්න පුළුවන් දසවාද ඔක්කොම ටික දෙනවා අපේ examiner. And this Q bar is fed as the J. Q bar තමයි fed කරලා තියෙන J විදියට. And K is always 1. එයාට clock signal යන්නේ මේක හැමතිස්සෙම 1 ලු. Right? So JK flip flop has J equal Q bar. වචනෙත් කියලා තියෙනවා. And K is 1 ලු. K එක හැමතිස්සෙම 1 ලු. Assume the flip flop was initially cleared. Cleared කියන්නේ මෙතන Q0 වලින් පටන් ගන්න තියෙන්නේ. Clear කරනවා කියන්නේ 0. මතකද අපි clear සහ preset. ඒ ඔක්කොම ඕන question එක කරන්න. So clear means initially Q is 0, Q bar is 1 on the starting point. And clock for 6 pulses. Make a pulse හයකට clock කරලා තියෙන්නේ. The sequence at the Q output from the following will be. මෙයාගේ output එක මොකද්ද කියලා අහන වෙන්නේ දැන්. හරි ඊළඟට එන්න මොනවද කියලා අහන්නේ. So this is super easy. If you since now you know how the JK flip flop works. Okay. Right. So the same question. Now remember, initially this is cleared. So therefore initially Q is 0. That means Q bar is 1. Okay. Q is 0. Q bar is 1 because initially cleared. And also K is 1. J ගැන අපි දන්නේ නැහැ. J ගැන දන්නේ නැහැ. But for the next clock pulse හැමතිස්සෙම K කියන එක න 1ම තමයි. ඊළඟ clock pulse එකෙත් මේ K වෙනස් වෙන්නේ නැහැ because it's hard coded to 1. So therefore this is always 1. Okay, this is always 1. Okay. Okay, right. Now what happens? Your Q is, sorry, your Q bar will be new J. මේ Q bar තමයි අලුත් J වෙන්නේ. මේ Q bar තමයි අලුත් J වෙන්නේ. So therefore this 1 will be this 1 and this is always 1. Okay. So remember in JK flip flop when both are 1, what happens? 1 1 කියන්නේ මොකද්ද? Toggle situation. So therefore your Q become 0 become 1 and 1 becomes 0. Right? And then that Q bar will be new J. Now new Q bar is 0. That will be your new J. Now we go to the JK 0 1 scenario. Remember J කියන්නේ S, K කියන්නේ R. This is like S0 R1. S0 R1 කියන්නේ මොකද්ද? Reset. So therefore your Q is now 0. Q0 වෙනවා කියන්නේ Q bar 1 වෙනවා. Right? Now that Q bar will be your next J. Q bar is 1. So therefore next J is 1. This is always 1. 1 1 means toggle. Toggle means your Q will be opposite the new Q, previous Q. So therefore, this is 1. When this is 1, this is 0 because Q bar must be invert of Q. Now that 0 is fed it here. Now again, this is something like S0 R1. That means reset. Reset කියන්නේ Q0. Q0 means Q bar is 1. So therefore, the output will be what? Q output එක හරිනේ. 0 1 0 1 0. ඔන්න හොඳයි යන්නේ. 0 1 0 1 0 කිය. So that will be the output of Q. Right, output of the Q. Assume this is a JK flip-flop and K is always 1 and this Q bar is fed as the J. So your output will be something like this. In JK flip-flop, 1 1 means inversion. But 1 1 situation එක ආවොත් එහෙම මේ වගේ ඔයාගේ අලුත් Q වෙන්නේ කලින් Q ගේ inversion එක. කලින් Q ගේ inversion එක තමයි වෙන්නේ. ඔන්න තව පාරක් 1 1 වුණා. කලින් Q ගේ inversion එක. අනිත් අවස්ථාවල මේක set වෙනවා reset වෙනවා. උදාහරණයක් විදිහට this is 0 1 කියන්නේ reset. ඒ කියන්නේ 0 නේ. 0 1 කියන්නේ reset. එකපාරක් reset කරනවා අනිත් පාර ආයෙ invert වෙනවා. ආයෙ reset කරනවා invert වෙනවා. ආයෙ reset කරනවා invert වෙනවා. හරි. ඔක තනිකර ගේම ගහන්න ඉස්සර JK flip flop එකේ truth table එක පාවිච්චි කරලා. JK flip flop එකේ truth table එක තමයි පාවිච්චි කරේ. හැබැයි මතක තියාගන්න ඕනේ මේ output එක තමයි ඊළඟ පාරේ input එක වෙලා තියෙන්නේ. හරි මෙන්න මෙයාව තමයි මෙතනට ගත්තේ. මෙයාව තමයි මෙතනට ගත්තේ. මෙයාව තමයි මෙතනට ගත්තේ. මෙයාව තමයි මෙතනට ගත්තේ. මෙතන hard code කරලා තියුණා 1යි කියලා. මොකද එයා කියනවා මේක දිගටම 1යි. clock pulse එක ආවට මොකද මෙයා දිගටම 1යි. okay. අපිට ඕන නම් මේක සමහරට කරලා බලන්න පුළුවන් වෙයි. අර රෙස්පොන්ඩ් කරයි දන්නේ නැහැ නේ. බලමු. let's give a try. හැබැයි අපිට ඕන මෙයාට clock එක එන්න ඕන edge triggering එකක් එන්න ඕන නේද? edge triggering clock එකක් දෙන්න ඕන. මම හිතන්නේ මෙයාව simulate කරගන්න පුළුවන් වෙයි කියලා. වෙනද preset එකයි clear එකයි clock එක. digital electronic තේරෙනවා කියන්නේ ඉතින් ආයේ මීටරේ සෑහෙන හොඳ වෙන්න ඕන. බල්බ් එකක් තාම cute. bar data print කරන්න. K is 1. අපි යාට 1 කියලා දාමු. high එකක් දෙමු. high constant එකක්. කියන්නේ දිගටම යා 1. okay. මෙන්න මේ clock එක තමයි හරියට ගියේ නැහැ. අපි initially clear කරන්න ඕනේ. flip flop was initially cleared. initially clear කරනවා කියන එක දෙන්නේ අපි. toggle switch එක දාලා clear කරමු. තමයි හරියට වෙන්නේ. K is 1, correct. Q is the output. This is cleared. Preset එක 1 කරන්න ඕනේ. Yeah, preset must be 1. දැන් හරි නේද? ඔන්න මෙයා දැන් 1 කරලා තියන්න පුළුවන් අපිට. දැන් පේනවද මෙයා toggle වෙවි යනවා. 1 0 1 0 1 0 වෙවි යනවා. මෙයාත් මේ 1 කරලා තියෙන දැන් 1 කියන්නේ දෙකම enable දෙකම enable. කොහොම නැත්නම් මට 1 එකක් high කරලා තියන්න පුළුවන්. මේක වැඩ කරන්නේ දෙකම high contrast එකේ තියෙද්දි නැත්නම් කොහොමද දැන්නේ? නෑ initially clear කරනවා කියන එකක් කියන්නේ නැහැ. Yeah, so that is not good enough. We have to use a normal thing, toggle switch and clear it. Clear කරනකොට තමයි මේක වැඩේ වෙන්නේ. ඔන්න මම දැන් clear කරනවා 0 කරනවා කියන්නේ clear. හරි? නෑ. Both must be 1, right? Yes. Now on you can see it's a 0 1 0 1 0 1 0 1 කතන්දරය යනවා. So that is exactly the question is all about. Question එක කියන්නේ ඔන්න ඔය කතන්දරය තමයි. හරි? මෙයාව ගිහිල්ලා මෙතෙන්ට කනෙක්ට් කරා. මෙයාට 1 කියලා දුන්න දිගටම. හරි? චුට්ටක් එකපාර මීටර වෙන්නේ නැහැ. So you need to think. So then of course you can go to the YouTube. My YouTube එකේ links ටිකක් දාලා ඇති ඔයාට. මෙන්න මේ reference ටික බලන්න අනිවාර්යෙන්. හොඳට explain කරන විශේෂයෙන්ම අන්තිම reference එකේ. හරි? Last reference. It's a series of YouTube. ඒකේ තමයි ඕකේ නෙමෙයි අන්තිම එකේ නෙමෙයි. පළවෙනි එකේ මම හිතන්නේ. මම screenshot ටික ඔක්කොම ගත්තේ මේකෙන්. හරි? So this explain everything in a very detailed manner. Okay. ඊළඟට ඔයාලට exercises ඕන තරම් තියෙනවා. For example, JK flip flop exercises. ගොඩක් ඉන්දියන් අය කියලා තමයි හම් වෙන්නේ හැබැයි. මේ තියෙන ඒවයි question එකක් නේද ටිකක්. ඒ තියෙන මේ question පේනවා. මේ question ගොඩක් කරන්න වෙනවා. මේ තියෙන diagrams එක. සොකට එක ඔච්චර ලේසි නම් හැමෝම digital electronical electronic engineers ලා වෙයි. හරි? හරි. ඒකන් දෙක එක පාට වලට වදින්නේ නැහැ. But definitely when you do more and more, because this is basically electronic. Okay, this is basically electronic. Okay, this is advertisement.
To 0.
So
and at every clock pulse, this Q output is observed. So here, we have been asked to find the output sequence at the Q output. So in this circuit, as you can see,
so try to do as much question as possible.
toggle. That means
It's
now
not easy.
this Q
If
will
it is
become
easy,
1.
of course, everyone will be electronic engineers, right? Digital electronic engineer. Electronic engineering का engineering वाला दिन हमारा subject है. It is not mechanical or civil or electrical, right? The hardest engineering field is electronic engineering. Electronic engineering. ඒ topic එකක් තමයි මේ touch කරන්නේ. ඉතින් ඔක තේරුන්නේ නැහැ කියලා දුක් වෙන්නත් එපා. හරි? හැබැයි පුළුවන් තරමට තේරුම් ගන්න බලන්න. Because it's good for your confidence. It's good for your confidence. Because this is basically digital electronic. Okay, digital electronic. And it's a very challenging area. Of course, අපි digital electronic වල මේකේ කෙලින්ම ගිහිල්ලා මේ resistors, capacitors නැත්නම් transistors level එකටම යනවා ඒගොල්ලෝ. අපි ඒක conceptual level එකේ චුට්ටක් තේරුම් ගන්න try කරා. Right. So we stop at this point. So in the afternoon session, we will be starting at 2, not 1. Then time එකයි නේ. We will be starting at 2. Maybe we can do පුළුවන් තරම් ඉවර කරන්න ඕන. අපි කරමු computer system paper එකකුයි maybe we can do paper on. Okay, let's start at 2:30. Right, 2:30 වල පටන් ගමු. නැත්නම් අපිට පැයක් මදි. 2:30. Maybe we can do FOSS and computer system. Right, FOSS and computer system. Some past paper questions. Okay, right. We'll be starting at 2:30. 2:30. Okay.